I think they're language designers. They want to design language. That means adding more stuff. And I think that, the reason to use C is to use a small language, and they want to solve all the problems. And I'm like, no, I'll write code instead. Oh, why can't we ship new versions? Why is this feature taking so long? Well, we were, busy fixing all the things that broke this week. Because as soon as you decide that all guns have this property, then you're gonna want to change that property, and then you're like, oh, I don't want to break my beautiful design and then you're fighting against good game design. You're making your game worse because you're like, but I made this nice code. That's bad.
So first, tell me, maybe we can actually start with a bit of an introduction, because there will be a line under your name, like, who are you? But maybe, let's say, like, who is Eskil Steenberg first, and then we get to how did you start programming?
So I'm a software developer. I run a small studio that does creative software development. I'm mainly a C programmer, or entirely only a C programmer. I like hard problems, and yeah, I'm trying to be a creative guy, and I'm also a little bit on the internet and trying to share with people how to do things. I'm also a member of the C standard board, although we can talk more about that later. I'm not working on the next standard. Yeah.
All right. How did you start programming?
So actually, I didn't really start programming. I started when I was like 14. I wanted to work in movies, and like that's a long dream of mine. I liked engineering, and I liked um, adventure and stuff. And when I was 8, I saw Star Wars and was like, that's what I want to do. I want to make movies like that. And when I was 14, I found out that you could do animations on an Amiga. A friend of mine had an Amiga with deluxe paint that you could animate. And I thought that was like the coolest thing ever. So I got really into that. And there was I didn't have a computer, but there was a community center that happened to have a bunch of computers, and I spent all my time there and never did any homework, and spent many, many years there until I was about 18. So I started in 2D graphics, and then I got into 3D graphics. I did quite a lot of 3D graphics, and I was, doing modeling, animation, and things like that. And then when I was 17, I was hired by a studio under EA to make a PlayStation 1 game, and it was like the dream come true. So I quit school and was like, I'm out of here, because I really hated school. I'm a dyslexic, and I can't stand, yeah, school basically.
So
So
you quit. You quit high school.
yeah. So
Okay.
I'm a high school dropout. And then my grandfather, who was a professor, he was very upset, but he got over it. We'll get to when. So I got to work on this little tiny studio. We're making PlayStation 1 games, and it was amazing, and it was so cool. And at the time, I was the only guy who could like talk to the programmers, even though I was an artist. So I became sort of the go-between between the artists and the programmers. And today we would call that a technical artist, or a TD, or something like that, but it didn't exist back then. So and then people were like, you should really program. You should try it. And I was like, I don't know. It's too much. And then somebody gave me a book called A Book on C, and I read that on a vacation, and I was like, yeah, this is doable. And then I didn't program very much, and then I started doing some other programming projects, like tiny ones. And then I was kind of just dabbling. And then I later I went through a couple of different jobs, and I was looking for things and to do, and I had this idea that it'd be super cool if you could network together um, computers that did graphics, especially 3D graphics. So if you could have like a model in 2 different applications and network them in real time, that would be super cool. And I I was actually walking down the street here in Stockholm, and there was a name on the door, and I don't remember what they called, but they were kind of like people who invested in like future technology. And I was just like, I think I read about them. So I just like walked in and knocked on the door, and I was like, hey, I got this idea. And it's like, I don't know. It's like, I have no idea what this place is or if you're any. It's just like, we just heard about you. It's like, and they're like, we don't really, I guess you could talk to this guy, you know. And they let me into a room, and he was like, this is awesome. We should make this happen, somehow. And he picked up the phone, and he called some guy, and it was like, yeah, I got a meeting for you. And it turned out that this was like around 99, so it was like IT bubble territory. And Sweden was, has always been pretty ahead in digital stuff. So it turned out that MIT wanted to start a campus in Stockholm. And this was like, everybody's like, yes, please, let's do this, right? And then eventually MIT was like, okay, you're going to have to pay for everything that is like, you're going to have to actually pay for the whole campus. And then we want $50 million every year so that you get to call yourself a part of MIT. And then, we'll send over some lecturers every once in a while. And Sweden was like 50 million. And it was like, this is crazy. So they were like, let's just do it ourselves. So they started this place called the Interactive Institute, and they had no idea what they were going to do, but they were just like looking for random ideas and so they hired a whole bunch of, collection of people. And I was the first one they hired.
Nice.
And I was like, well, this is crazy because I'm not really a programmer. Like, I've written a few lines, and I read that book like 2, 3 years ago. How's this going to work? So I asked, it's like, no, we need a team of 2 people. So I had a friend who was a really good programmer, and he sort of helped me get going. And that's really how I started. So the first thing I ever programmed was Verse, the networking protocol. And the second thing I ever programmed was a subdivision surface rendering engine, essentially.
That's a
So
wild
that's
start. That's a
yeah. So it was
wild
a bit
start.
crazy, yeah. But it was a really fun place, and it was mad, and there was like too much money around, too many crazy people, but it was fun until everything, uh, everything fell apart, kind of. But yeah.
Okay. So you mentioned that the book on C. So you get the experience from there,
Yeah.
and then the friend of yours. So this was like a combination of book in free time for the introduction and some other people influence to get started.
Yeah, but I think one thing that's kind of interesting about me, and we'll get through the whole story, but I never, for a very long time, I never ever worked like in a big team or like with other programmers. And my friend is like had a proper education, and he knew what he was talking about. But it was still sort of a low level C programmer kind of guy. And it was still sort of early that people were like that. Nowadays, like if you go to CS, all you learn about is, I don't know what you learn anymore, but it was like, it was pretty hardcore. I mean, he came from the Amiga scene and, programmed assembler and things like that. So, it was kind of from that culture, and I'd, been in that world. But so I programmed for many, many, many years alone, and sort of just figured it out myself. And I have a massive bookshelf here. I'm setting up a studio, and we have a massive bookshelf. We're actually calling the studio the library because the library is so big. But if you look inside here, there's like 10 books about programming, and then there's like 150 books on like art direction and art and comics and like every kind of, I have more books on photography and architecture than I do about programming. So I was like, and the most of the ones that I have about programming I haven't actually read. So I've sort of developed my completely own style, right? And for most of this time, I was just like, for many years, at least 10 years, I didn't call myself a programmer. Like, programmers are real people who write real code and I'm just writing code. That's a different thing. I'm just like goofing around here. Um, and then I would hear people say like, "Oh, you should program like this or like that." And I was like, "Well, that seems strange to me, but I'm sure they're right." And then further I went, I was like, "I don't think that's the way to do it. I think people are wrong. I think computer science is wrong." And then I also started sort of hearing from, the people I really look up to, like the best programmers in the world that I come in contact, they would sort of, if you meet them at like game developers conference, like in a bar, they would be like, "Well, actually, I don't follow those rules. I don't care about that. I'll do." And you would hear that people are like, "Oh, actually people that are really hardcore, they kind of do it my way." But that's not how people are teaching it. But the difference is that I'm kind of virgin because I never ever got taught the different way. So it's like, even when I talk to people who are really good, who are really far in my direction, they're like a little hesitant about saying they're doing these things. So they're a little hesitant of like admitting it, or like, I don't know. It's I feel like they're a little damaged from sort of what's being taught, and it's like they don't want to come off as bad, or like, and I just stopped caring at some point. And so a bunch of years later, I was like, I'm going to talk about how I do it. And that's where I gave a talk. A friend of mine just asked me, "Come to Seattle, I'll give a talk." And I was like, "Okay." So I gave my first programming talk, and it was like 2 hours long. And then I was like, "I got to record this." So I recorded it and I put it on YouTube, and there's no camera or anything. And it's got like 800,000 views now. And I'm regularly referred to as that guy who did that video. That is awesome. So it's sort of, it's sort of, I had no idea that it was going to get that big. But then I think that was kind of the start of me caring about, being more assertive about how to program, I think. So yeah.
Okay. Uh, you mentioned that there are people that you looked up to in terms of like who know how to program. Do you want to make some of the names public of your
Yeah, I
influences? Or
mean I mean, if you grew up when I grew up, like John Carmack is like a total badass in many ways. And I've met him once or twice, and um I'm good friends with actually some of the people who developed Doom. Sorry about the noise outside. I worked at id, so I have some secondhand. But there are other people like that. Like, um I look up to people like Linus Torvalds, obviously. And who else? Jim Keller. He's not a programmer, but like, just this is an engineer. There's a lot of people like that that I look up to, that are like really hardcore, and aren't afraid of low level stuff, and aren't afraid of getting their hands dirty. So yeah, but I don't know. I look up to a lot of people, in a certain way, but I also sort of, I think everybody should program the way they want to. So I have a special style, and I'm sort of preaching my style, but I also want people to sort of ignore my style and, do whatever they want. It's like, so I wouldn't say like I don't look up to people in terms of like, "Oh, I want to write exactly like John Carmack's code." There's like aspects of his code that I don't like, you know, and yeah.
Mhm.
So
Okay. So let's go back to verse. Maybe you can paint a picture what verse is and what it allows for.
yeah, so Verse was, although I'm still using it all the time, is a network protocol. It's an API you program for, and you can basically exchange 3D graphics. So, textures and meshes and things like that. And everything is real time. So at any time you can say, oh no, this vertex is over here, or let's add some polygons over there, or let's change these pixels. And that allows, if you integrate this into applications, you can actually get them to collaborate. And so all of my tools that I've written that use this act as if they're one tool, even though they're different tools. So you can have different interfaces for different people, and everybody's just like real time, you know. And when we get to games I've made, they've used this, so you can sit and model in your modeling application and see the model change inside the game and make it work. And you don't have to save or export or anything. So it was a pretty bold idea at the time, and if you want the modern version of that, it's Omniverse is very similar to what I was doing. The problem with the whole project is basically you have to do integration, and nobody wants to do integration, and especially Autodesk doesn't want to do integration, but they want to own everything. So that kind of sucks. But yeah, so I worked on that for a couple of years at least.
I would think that this is a super cool idea to have for example, Blender open, and then you can
Yeah.
modify the model, and then you have your game in an engine or whatever, and it's live updated in real time right now.
Yeah.
Why this is not a like primary way of doing this? Because right, like
Well,
all the exporting and like inverting normals
yeah.
and blah blah blah, and
It's
like
it gets generally complicated to do that because like different applications have their own internal representation, and that makes things very difficult. And the VFX world is kind of doing this right now because they are somehow trying to move over to USD, uh, which everybody says USD is great, and it is. I know some of the people who made it. They're great people, and they really understand how movies are made. So it's a very clever format. And the problem is like you kind of have to rewrite your software to support it. And it's like Maya is not going to be rewritten anytime soon. Let's just say that. So the integration is very, very tricky because you kind of want to structure everything around that data model. And I think that format today has the clout to sort of be the thing because it's pushed by big industry companies and things like that. But it's it's still very, very difficult to do. So yeah, I think a big lesson that I had was in the whole project is like never ever do anything that depends on somebody else doing something because it's
oh
like
yeah.
that's a bad idea. So yeah.
Okay.
But I mean, it got me started, and I'm as I said, I'm still using the tech all the time. So
And you also worked on a modeling tool. Uh,
yeah.
I am concerned with the pronunciation.
Locaro is the
Look a row.
I'm
Okay.
funny with names.
Oh
Yeah,
yeah.
so it's a sort of sketch-like subdivision surface modeler that I wrote, where there's actually no like visible UI. You just draw things and then you can make them into 3D and you get subdivision surface models. And it's pretty cool, and lots of graphics and stuff I've made is made in that. So all the assets for my games, lots of things. If you're watching the video, you can see all the stuff behind me that has been like logos and characters, and yeah, it's like lots of things I've made in that. So
And subdivision surface modeler, it's maybe we can define a little bit how it works compared to like Blender and like even
yeah,
sculpting.
so subdivision surfaces is a technique for creating smooth surfaces, and it was invented by uh, Ed Catmull and whoever Clark was, Catmull Clark. And basically what you do is you take a normal polygon mesh and then you just split all the polygons, and every quad becomes 4 quads, every triangle becomes 3 quads, and then you sort of have an algorithm to round that so that it becomes slightly smoother, and then you just do that multiple times. You get, you know, quadruple the amount of polygons every time you do it, and eventually you get a smooth surface. And what's really, really neat about it is that you can use it as like higher order curves like NURBS and Béziers and things like that. But those are very limited in that they have, you know, they're basically a grid. You have a fixed topology, and that means you have to do a lot of managing of stitching and yeah, getting continuity is like really difficult. But with polygons, that's super easy. You just like build any polygon mesh, and then you can do this operation to become smooth. And why is the subdivision surface in my application different? Well, subdivision is a, you know, you can make a normal poly modeling tool, and then you can just, once you model your thing, you say now smooth it, and then you just apply a thing that makes it smooth, and then it's done. And that's kind of what Blender and a lot of applications do. What my application does is that you're always modeling the sort of cage, the poly mesh, but then automatically what you see in the viewport is the smooth surface. So the user works with it as if it was a curved surface, except they don't have to care about topology. The topology can be anything they want. They can work on it as polygons, but they get a smooth surface out. And they don't have to apply, you know, a filter or anything. It just happens right in the viewport. And unfortunately, there's not too many modelers that work like that. I think Modo did. I don't know if Modo's really around anymore, but it was a really cool modeler, by the way.
And both of these programs, they're in C, written in C, and
Yeah,
also C
everything I've ever done is in C. Like, yeah.
and C89.
Yes.
Okay.
So I write very old school C, and I'm I it gets to a lot of different things, but one of them is that I want to write code that is incredibly simple. Like I don't believe in making complicated syntax. Like I believe that you should write everything out and be super explicit about everything you do, and then it's easy to follow what's going on. And it's like minimum number of abstractions, like everything is done the same way every time, so therefore you get this sort of, you can always see what's going on, very little macros or anything like that that sort of can hide anything or make you do weird things. It's like everything is very, very straightforward. And I don't think that the later versions of C, and this is a long discussion about C, have
Yeah.
added anything that is like a requirement for me. But they've created up more issues, in my opinion, than they have solved. And now I'm in the, you know, VG14, so I'm part of the discussions about future versions of C. And that has been an amazing experience because I'm pretty damn good at C now. Um, but I'd say like most of the issues with C and most of the things that are talked about are things I don't care about. Like I don't really care about any of those things. Like the future versions of C, not
We'll
that's
come
not
back.
what I'm
We'll
interested.
come back to
Yeah, we'll
that.
come back
We'll
to
come
that.
back to that. Okay. So next on the journey, on your adventure, is the mythical game called Love.
Yeah. So there was a few more twists and turns before that
Okay.
because I was working with on Verse for a long time, and we got a big EU grant for a couple of million euros, and we put together a big consortium of people, and Blender was part of that. So I became good friends with Tom Rosendahl, and it was a lot of good stuff. And I got to work as a researcher at a university. So my grandfather finally like let go of how I was a failure, because it was like, okay, that's cool now. You know. Um, But I got really tired of, like, a couple of things. I got tired of trying to get other people to adopt my stuff, and the other thing is, um, I'm academia is a place where really, like, there's a lot of great things about academia, but academia is a place where reality doesn't matter, but a lot of really stupid things matter, right? It's like people fight really hard about some really inconsequential things. Um, and I was like, I don't want to spend my life here, you know? And I also think it's like, I don't know, I've I always had a little bit of like, I like teaching people other things, you know, but I'm really conscious of not being a teacher, if that makes sense. Because it's
No,
like,
no, no. Can you explain that?
yeah, it's like I don't want to be a teacher in sense of like I spend like, especially when once you get slightly older, I think a lot of people go like, I don't want to do anything anymore. I'm just gonna be the wise man who tells the young people how to do things, and I'm gonna
Okay,
walk around with my wisdom, and and it's like you drift further and further from reality, and you're just
okay,
like, it's just sort of second order influence over the world, and you pretend you're influencing people, and maybe you are, but it's like, I don't know. I think it's great to share information, and I'm super like, but I don't want that to be the primary thing I do, I think. So, yeah, where were we?
so we were discussing your venture into the academia.
Yeah, my venture out of academia was this, I mean, um, yeah, so I wanted to do something, and I'd been a member of the OpenGL Architectural Review Board for a bit, so I was actually very, 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 very tangentially part of designing the shading language and a lot of the changes that happen around like early modern OpenGL, as if you could say such a thing. So I knew I could do graphics, I knew I could do art, I knew I had a bunch of tools, I knew I could render. I sort of realized one day, it's like, I can make a game. I've done networking, I've done like, there's no part of a game that I can't make. Like, I can do everything. Like, there's like, I've been an artist, I've been like, I can do anything. So, I started making this wildly ambitious game, which was a first-person action adventure, multiplayer, procedural game where I wrote everything from scratch in C. And it was a ginormous amount of work. And I spent almost 10 years on it. Like, so it was a pretty huge effort. Um, and it went terrible in many ways. So, yeah, um,
And 3D, you didn't mention that it was 3D, which
yeah,
which
it's a
adds to
first
the
person
scope. Yeah, yeah.
action, game, so it's a shooter in many ways. So, yeah, um, and, yeah, so I learned a whole bunch on that project. I think the big mistake I made, and I see this everywhere in the games world, is like, let's build an amazing game where everything can happen and just put the players in, and then amazing things will happen. And if we just like simulate the world, it'll be great. And it turns out we're already living in a really, really, really good simulation where everything's super detailed, and we still choose to play 8-bit Mario. So complexity is really not the thing you want to do. So it was it was tough. I had a lot of I had a lot of I was pretty depressed actually, because it failed spectacularly in lots of ways. And there was a while where I was like, I'm not gonna program anymore. I'm just gonna do something else. Like, I don't know, write books or whatever. Like, I don't it's like I was pretty out of it. But then, so I had this experience. I'm gonna tell you the sort of the turning point in my life.
Okay.
Um,
Okay.
so, there's a game company called That Game Company, if
Yeah.
you know of it. Yeah, they're pretty famous, and, there was a couple of people there, um, Kelly Santiago and a couple of people that I knew. I'd run into them at Game Developers Conference and, um, like,
These are the
truly
makers.
lovely people.
These are the makers of Journey and
Yes.
Flower.
Yes. So I got to visit them during the making of Flower, and I got to visit their studio in LA, and it was great. And then we're all sitting down talking about like the game. I got to play the game before it was out, and it just got really tense in the room. Like it got like man, it was like I don't know. I felt like I said something stupid. I was like it got bad. And I was like, "Okay." So afterwards, I, like, sent my message, I think it was to Kelly, I sent a message like, "I'm so sorry about this." Like, um, um, I'm really, like I didn't mean to mess everything up. So I got you know, time went by and they released the game, was a huge hit, and, we met every now and then. And then a couple of years later, they were making Journey. And they were like, "Oh, you gotta come down to the studio. We got a new studio. You gotta come see it." And I was like, "Okay, let's do that." So I went there and I saw Journey before it was released and before it was out, and I got to play a little bit, and then we talked about it, and it got really tense and like I don't know, it was like, oh, the air was thick. It was just like people were mad in the room, and I was like after that, I was like, "I'm never visiting this studio ever again. I love you guys. You make great games. I don't like no offense, but like I should not be in your room. Like, cause I don't want like when I say what I think, you should ignore that. If you don't like make your game, you're great at this. Like, don't listen to me. Don't like be upset about what I said. Like, just like do your thing and like please don't ever invite me again." And it's like it's not a diss. I love you guys. And I was like, "Okay." And then a couple of years later, I mean, so the game was released. It was a massive hit. It was like making so much money. It was the biggest game on PlayStation download ever. And it was like, everybody was like, "Oh, this is a new art form." And it was like, "Oh my God, they got so much praise." And deservedly it was a great game. So and then I went to somebody from Game Developer Conference Europe was like, "We need somebody to talk about programming. Will you come?" So I got invited to there, and I was like, I was so depressed at this point. I was like
Mhm.
completely ruined from my bad experience. And then I'm not going to go into details, but essentially there was somebody there from that game company, and they had like a post-mortem of this game, and they worked on it for I think 4 years or something. And it was apparently like a constant war where everybody in the studio hated everybody else. And it was like there was this machinations of them trying to fire each other and like steal each other's um, you know, equity. And it was like, somebody lost their marriage. And I was like, they hated each other to no end. And it's like, I was like, "Holy shit, was that going on when I was there?" So they go, "Yeah, that's why, as soon as you said anything, you took side in this war, and that's why everybody was mad. It was not because of you. It was just like that was the war we were having, and it was hell." And it's like people had to like I don't know, people had like stomach aches, and it was this nightmare scenario. And I was like I had no idea. I had no idea whatsoever. I was just like shocked, right? Because it was like, okay. And then I thought about it. I was like, okay, wait a minute. They spent 4 years of hell, and then they had this massive success, and everybody loves them, and everybody thinks they're geniuses. And I had like the opposite. I've had so much fun making this game. I, it took years and years, but I've had so much fun. And then it ended with a thud. Like it just came to nothing. All this work came to nothing. And I was like, I don't think I want to trade. I think I got the better end of the deal. I think actually it was like, no, actually, I did the right thing. Like I didn't hang out with people who hated me. I had fun. And the fact that nobody liked it, including me, by the way, is cool. I can live with that. That's okay. And that sort of got me back. And I was like, that changed me to the better, I think. So that was like that was a very, very big part of my life, I would say.
So
Um,
when you were in the offices of that game company, it was like somebody asked you about like, oh, what do you think about this? And you said,
no,
I
I would
think it's
just say like,
great.
"Oh, have you thought about changing this?" And what I didn't know was like they had thought about that for 2 months and we're all
Okay.
super mad at each other. And here I come, "Oh, I have an idea." It's like, "No, no, no.
Okay.
They all had that idea." It was like I was just like putting some salt in some wounds but I had no idea, right? It's like I
Okay.
didn't know there was a war going on. I was just like, "Hey guys, have you thought about this?" So yeah.
So you were not shredding the game. You were not like, oh, this sucks. Oh, this is bad.
No,
It's
no.
just
I mean,
okay.
it was great. So
Okay. So just saying anything about it
say
was
anything, like have any suggestion was probably a bad idea in that room. So it was like, okay, well, yeah.
I think you're very harsh on Love, the game. When I read about the game, like right now, there are people that say that like this game was like unlike anything else. It was mystical. It was changing over time depending on where you went. Like it's as if this is half like a social experiment, half like a dream. It's a unlike any other thing. But you're very harsh on on the result of the game. Why is that?
Yeah. For many reasons. I think it's important to be harsh on your own stuff, right? It's like you got to be self-critical. I think that's important. And I think all those things that you just said are sort of true. Like I can totally see all that. But I also think it didn't really come together. And I think game development is ridiculously hard, and it's hard for other reasons than people think it's hard. Um, Most game development or game design works something like this. I like Diablo. I like Half-Life. What if there was Half-Life with some Diablo in it? That's the game we should make. Or like, I like Diablo, but what if everybody was a pirate?
Yeah,
That's kind
oh
of
yeah, yeah.
how. But what I'm interested in is like, how do you build a new genre? Like, how do you analytically understand why something works as a game or not? And that is much, much harder. And I think I figured that out after pretty much abandoning Love. There is a version of Love that sits on my hard drive that has fixed a lot of things in terms of gameplay. And it's actually a lot better now because it was like I so after I finished, I took a couple of years off, and then I thought about like games, and back in my mind, it was like if I could do it again, here's what I would do differently. That's what I thought, and I took like I think I took a month and was like, I'm gonna see if it will work, and I did, and it was like I got the feeling I was like this might have worked, but I'm like I'm not. There's too many things that are broken. There's like too much to finish. It's too rough for it, and I'm like, it's too much emotion. It's like I'm
Mhm.
sort of done with that part of my life, so I'm sort of that's kind of as far as I wanted to go. Was just like, you know, I wanted to know that I kn- I could solve it rather than solve it,
Yeah,
if that
yeah,
makes
yeah.
sense. Like I wanted
Yeah.
to be like, okay, I can stop thinking about this now because it's like I know what I did wrong. I know, you know, and so I kind of want to release it as open source.
Oh,
But I'm, because it just sits on my hard drive. Why not? But um, there's some broken stuff in it, and there's also, I mean, the code is not pretty in many ways, and one of the reasons it's not pretty is because um, I spent, better part of a decade just trying random stuff, and if you do that with a code base, it doesn't, like, get pretty, kind of. So, so I'll, you know right now I'm very busy, but if the public is adamant enough, I might take the time to do it at
uh,
some point. So, yeah,
everyone,
we'll see.
let
Yeah,
Eskil know in the comments.
yeah, I guess.
You
Damn,
could
I gave
you
myself more work now.
you couldn't have picked a better name for a game that is like emotional baggage right now, and
Yeah,
this
yeah.
like to call it love.
Oh, yeah. I mean,
It's
I had a small
oof.
community, and there was, like, no end in jokes of, like, Eskil is making love again, and, there's
Yeah,
all
yeah,
those things, um, and a lot of hadaway because people were like, "What is love?" And
yeah,
there's
yeah, yeah,
like,
yeah, yeah.
yeah, yeah. So there was a lot of jokes around that.
If you look back, you mentioned that you came back and you fixed some of the things. So conceptually, what wasn't working in the original version, and then what was fixed? Like, what was the lessons learned from this?
So there was a lot of things. I want to keep some of that secret because I'm starting a new
Okay.
gaming studio that is, like, based
Yeah.
on all these ideas.
All
So
right.
I wanna be like, um, but I can say this, at least I think it's like, I think that kind of game needs to have a sort of good imbalance in it so that, like, when you're in one set of circumstances, those over time will tip you into another set of circumstances, and those circumstances will tip you into the next one, so that you get sort of a live world that is constantly, like, evolving, and Love was able to do that even before then. It would have, like, moments of that, and that's kinda where, like, I understand people who say it's amazing because there were things in the games that y I've never seen in a game before. Like, you could go to a village, and when you're in a village, there would be an attack from another village that would be 100% procedural, and they could destroy that village, and you could help defend that village, and there were, like, dynamics like that that you just, like, you don't see that in a first person shooter. Like, that village gets destroyed, and the AI will build a new one somewhere else, like, while you're playing. It's like there was things like that that were, like, kind of breathtaking in a way, and it sort of has the scaffolding of something really amazing, but it's like, it doesn't really come together. It doesn't really, you know, work all the time, and so it's like, there was definitely moments of it where it's like, there was definitely, like, arresting moments. I think that's the most positive thing I can say about the game. So yeah.
And you needed to run servers for this, right?
Yes, that was a big problem, and that's, um yeah,
Okay.
that
And
that cost me a lot of money.
yeah, exactly. So this was probably the tricky part to keep going. Like it's difficult if it was like single player game, you could just leave it out there, sort of.
Yeah.
And
So it's not just that, there's more, and that's one of the problems with releasing it is eventually I made it so that anybody can buy and set up their own server, but you need a master server to be able to find other servers. So you need to still run a
hmm,
server, and I'm working on a bunch of tech to get around that, and now I actually have a server in my house, so I could run it. But yeah, there's a
Okay.
lot of work to make
Okay.
that work.
So we finished the love discussion, and how from love we get to EXO.
So EXO was actually, I mean, still is. EXO is a real-time strategy game that I've been working on for over 10 years, but in a completely different way. So I wrote an engine in like maybe 8 months or something like that, and then I worked on the game. I've worked on the game for like 2 weeks every year or something like that. So I've been sort of constantly thinking about it, and I was like, I should change this unit like this. And then it was like, I'll take a week off and I change it. And then I was like, I don't know, I'll just think about it for a couple of months. And then, oh yeah, let's do this. And I think in many ways it was like therapy of making a game like that. And it was also sort of just like figuring out how games work, and learning a bunch of stuff.
In what way?
The, well, just like having a play field, right? Having, if you have a game you can work with, you can take ideas and put in that game and learn things. Um, the really stupid thing about EXO and why it's not finished for sure is that don't ever make a multiplayer game alone. It's just like I keep making that mistake. So, but I'm probably gonna make something with EXO in a little while. Right now, I'm super, yeah, we get to what I'm working on right now.
Okay.
Um, but essentially what happened with EXO was, um, so one thing I did wrong in EXO, was that I made everything data driven, which is a really good way to build things, right? You want to, if you do any kind of software development, like if you can generalize things, that's a good idea, right? You want, if you can say everything is a file, that's great. If everything is this or that, or like you can generalize things, that's a great idea. And EXO is extremely generalized. So all units and all items in the game are the same thing with just different settings. So you can, change anything. Everything is just a bunch of numbers. And that's a great idea for everything except for games, in my opinion. uh, because what I learned was that um, anytime you can every time you generalize anything in a game, the game gets worse, right? It's like if you have two guns in a game, you don't want them to just be the same gun with just different stats. You want one of them to be a hit scan and the other one to be a projectile, and then, the next to be, a thing that spews fire that sticks to things, and the other thing to be a hook that pulls people in, or like you want every gun to be completely different. And like if they share one line of code, that makes them worse, right? So you want actually in gameplay, like if you start thinking about those things as a programmer, so like, I'm gonna make a weapon class, or some, like, no, don't do that, right? That's like great for all other programming, but not for game development. Because as soon as you decide that all guns have this property, then you're gonna want to change that property, and then you're like, oh, I don't want to break my beautiful design to, and then you're fighting against good game design. You're making your game worse because you're like, but I made this nice code. That's bad. So I actually think that it's like game development needs code that is completely non-generalized, kind of. That is a good thing. So um we're jumping ahead a little bit here, but um I got to a point with EXO where I was like, this engine really sucks. And I know that now. And then kind of precisely a year ago, my family, um, my son and his mother, they went on vacation without me, and I had a week off. And
Yeah.
I'm like, I'm gonna rewrite the engine. So I rewrote the whole engine in a week, like pretty much. And then I was like, this is awesome. Like, I want to make 1,000,000 games in this engine. Like, you could start a company just making games in this engine, because this is like, this is prototyping heaven, And then I started thinking about it. I was like, I'm going to start a studio. So, so now that means that EXO is like on ice, because first of all, I don't want to ever touch that code base again. So if we, if EXO is ever alive, it's because I re-implemented in the new engine. And we'll see when I have time with that. But yeah, so
Okay.
EXO is kind of in a certain way it's dead, But yeah, we'll see what happens.
Okay. Okay. Uh, there is we're now getting into like a bit of a packed chronologically area, I think, because there is
Yeah.
a Shimmer Eskil Lights project. There's also the OPA. I think OPA was chronologically earlier, the debugger.
It was kind of so
OPA.
OPA is yeah. So OPA is Korean slang for big brother. Or like
Okay.
older, and since it's a program that overwatches, keeps track of what you're doing. I thought
Okay.
Big Brother, and that's what Oppa Gangnam Style is from, because Oppa means,
Oh, okay.
So yeah. I was visiting Korea around that time, so that's why I named it that. But I wrote it in like 4 weekends, while doing other things. So it was just a prototype of like what you could do. And what it does is that it's a function you put inside your code, and it takes a pointer, it takes a string, which is the type name of that pointer, and then um, a string, which is the header file where that pointer is, that type is defined, and that's it. And what it does then is that it sends that pointer and that information over the network to the program. And then that program parses the C file, figures out the memory layout, and knows what's inside of that pointer, and then sends a message back to the program and be like, oh, that that's nice. Could you give me like this many bytes into it? And then it sends over those bytes, and then it's like, aha, now I can display that on a second screen. And then you can have a pointer in that, and since you parse it, you know what type of pointer, and you know what the content of that is. So now you can ask the program like, hey, can you also send me this pointer and this many bytes forward? And then you can actually traverse the whole, like, a whole graph of structs that point to each other. And you can also send messages back where you say, on this address, could you please overwrite this with this value instead? So therefore, you can sort of poke into memory of the running application and change things, which is a sort of pretty neat thing.
Yeah.
So yeah, so
And
that's what OPA is.
it also looks wild, like all of your products, by the way. And there is a video of not like a tutorial, but like a showcase of OPA on your
Yeah,
website, and it's awesome. I
thank
highly
you. Yeah,
recommend
you can find
everyone
it
to
on
watch
YouTube.
it. It's awesome. Uh, do you use it regularly?
No, I never use it actually, but
Okay.
I am working on something more advanced similar to it. So one of the problems is I had to write my own C parser, and the C parser I wrote was a little bit hacky, to be honest. And I've since written, like, I keep coming back to, I need to write a compiler at some point. For no other reason to learn C, but also I need my own shader compiler. So it's like, it's on my to-do list to write a compiler. But yeah, for now, I'm gonna have to live without it. So it doesn't sort of work. It works sort of on my C code with some limitations. It doesn't work on all C code. So it was more a proof of concept than like, I'm gonna make this into a product. So yeah.
Why did you say you had to write a C parser?
Yeah, I mean, I didn't have one, so then you have to write one. So yeah.
Okay. I love the quote of yours from Better Software Conference that you don't have the not invented here syndrome because you invented everything here. This was really cool.
Yeah, I mean, so I have a lot of libraries. I have my own platform libraries. I have two of them, basically like SDL or you know something like that. I have UI library. I have rendering libraries. I have everything. Like I load PNG files because I have my own PNG loader, and it's like I do that. Like that's partially it's about keeping control over things, but it's also about learning. Like actually, a lot of times learning a API for a thing that does something, you know, takes a while, and actually implementing it from scratch doesn't take that much longer. But then when you do, you know it, right? It's like I think there's a lot of things like that. It's like, you know, I knew what an HTTP header looked like, but I really know it now that I've implemented a web server, right? Then you really know it, and it's like you get to that other level. So yeah, I like doing things like that, and it's usually yeah, it's the kind of thing you can do in like you do it in a couple of days, and then you just have that capability forever, right? I don't ever have to find a copy of libpng. I don't have to because I just have that code. I've solved that. No, but there's things in libpng that people argue is wrong, and my library doesn't do those things, so I'm happy. I don't have to care, and it's like you know, so.
Yeah. When did you step out from the pure software into the Shimmer and LED lights project?
Yeah, so it was kind of I've I've been poor for most of my life. Um, I've um I've never been interested in money to begin with. I've always been more interested in doing whatever I wanted. And I've been lucky in many ways. But a big part of being able to do all these things is living very, very cheaply. And you know the expression of FU money?
Yes. Yeah.
Right. So everybody wants enough money so that they can tell anybody to F off, right? That's kind of the goal in life. And it's like one way of doing that is making a lot of money, but another way of doing that is needing very little money. So I've been going at it from that point of view. So I've always had very little money, but um, sometimes I've needed money. And I was in San Francisco, and I met a bunch of people who were doing LED installations, and they were like, "Hey, we need like a 3D application to do, design 3D light installations." And I was like, "I can build a 3D application in a couple of weeks. What's the problem? My libraries do that." And they were like, "Amazing." So I worked for them for a while, and I built a program called Stellar. And then that program sort of failed for various crazy reasons. And yeah, the CEO was jailed for 4 years for possession of marijuana. So that's
Okay.
that's an adventure. Um, but I written this software, and I didn't have a contract with them, which meant that I actually owned all the software I've written, and I'd been very
Oh.
careful to keep all the rights to everything. So I owned everything. And then I got contacted by some people who were like, "Hey, you should do something." Some people in the lighting business. And I was like, "I don't know anything about lighting." So I was like, "Whatever, if you want to do something, go for it." And so I wrote some paperwork just basically saying, like, if you can make something out of this, we'll have a deal. And then it took a couple of years, and then they came back and were like, "We're going to start a startup around this and get a bunch of venture money, but we need you to be part of it." And I was like, "Okay." So we started a company called Shimmer Industries, and I became the CTO and got to build a team. This was during COVID, so it was crazy time. And we worked on that for a couple of years, and it's a terrible, terrible business. I now know. I didn't know that's why I said, you should take care of the business because I don't know anything about the lighting industry. Now I do, and it's terrible. Uh, so it failed for all kinds of reasons. And one of the things that happened was that the CEO left the company, and I basically had to become CEO because I was like the only one. And I was like, okay, I'm a CEO now of a startup, and I have VCs, and I have to have board meetings and all that stuff. And I pretty quickly came to the conclusion this will never work as a CEO. I was like, this will never work. So I basically had a board meeting and told them like, you should take your money back because this is dead in the water. And their response was, no, don't worry about it. Like, take it easy. Just think it through. Think what you can do. Keep the money, be cool.
Okay.
And I was like, okay, that was not what I expected. Um, so I thought about it and I was like, okay, one of the big problems was we're making software and we needed hardware people. Again, same mistake. Don't do anything where you require other people to do something for it to work. But I worked with a bunch of business people who like wanted to do business deals and found out they couldn't. So I was like, okay, we didn't have much money left, but we had like a couple $100,000. And I said like, okay, if we don't have a hardware light, we can't, like, nobody wants a lighting control system that doesn't control lights. That doesn't That's not a thing. So it's like we need to get some lights. We need to build lights. We need to be a hardware company. And they were like, that's never going to work. Like you need $10 million for that. And I was like, I'm not sure. Like I want to find out if we can be a hardware company. And they said, okay, and then they said like, you can't spend all this money. I was like, I don't want all this money. It's too much money. It's like, okay. So they were like, you can spend $50,000. That's all you can spend. And we used to have a run rate of, I think, $80,000 a month. And I was like, I can build something in 50,000. I can build a product in that. Turns out I couldn't, but close enough. So I basically am now building a very, very, very high-end luxury brand of light fixtures. And we're not quite ready to reveal them yet.
Okay.
But it'll be the Lamborghini of light fixtures. It will be insane. So I spent the last 2 years learning how to CAD, how to machine, how to talk to like Chinese manufacturers and negotiate and build things, and gotten a 3D printer, and dealing with like PCB manufacturing and all those things. And it's been amazing. And we now have a prototype product actually on budget, but we're going to make another revision, which is going to cost us a little bit more. But I'm super excited about it. And I learned like an enormous amount. So right now I'm sort of, mostly a programmer and mostly a runner of a game studio, but on the side, I'm also sort of a hardware entrepreneur.
But
And
you're still a CEO of this company?
Yeah, I'm still CEO. I mean, there's no employees, and I haven't had a
Okay.
paycheck in 2 years because I was
Okay.
like, I told them like, if you don't take the money back, I'm not going to take the money. Like I'm not, if I'm going to take a paycheck when this is a real business. I'm not going to take a paycheck because there's money in the bank. I mean, it's like, um, so I've been working for free on that, but it's like, I love my investors for allowing me to do that. I mean, to them it's peanuts, but still, like giving me the trust to basically say, hey, I've never manufactured anything, but I'm gonna learn how to do it, and I'm gonna make something. And yeah, so it's super, super fun. And
You're doing this like after hours.
yeah. Well, the thing is that hardware manufacturing is incredibly cheap these days. Like making things is very, very cheap. And um the problem with hardware is that it's very, very slow, right? If you want a part, you can specify it and you say, here's what the part I want, and you send that off to manufacturing, and then it can take like months for you to get back a prototype. And then you're like, oh, this was a little bit wrong. And then you
Yeah.
change the CAD model, and you can do that in an hour. And then they're like, okay, we'll get you a new one in two months, right? So so if you have like a staff of 10 people that you're paying salary, and you have an office, and that's just like murderously expensive. Like that mistake is just like unrecoverably expensive. But if you don't do that, if you're just like, I'm not going to take a paycheck, I'm going to, let the money be in the bank, only pay for the things that I spend, then it's actually really, really viable, right? And it's like, it's amazing what you can do these days. It's amazing. And it's like all you got to do is start trying. And my apartment is full of junk because I just like I draw junk in my CAD program, and then I'm gonna send it off to manufacturer, and comes back, and I'm like, oh, they didn't, they'll complain. They'll like, we can't make this corner. Great, now I know you can't make those corners, right? So it's just like I've been doing that for 2 years, and it's like very, very slow. And I got a 3D printer, and I'm practicing CADing toys for my son. And that's like I'm making like fake Paw Patrol toys for
Nice.
him, just um to get better at it. So yeah.
Okay. Okay. How do you divide your time between game studio, hardware things, shimmer, and other stuff?
Uh, so my day usually looks like this. I usually wake up in the morning and I take my son to preschool, and then I go to the office and work. And now I have a studio. I tend to stream a couple of hours, and that's when I do most of my hard work. I was invited to a party a bunch of years ago by Intel, and they were like, "We want you to live program in front of an audience." And I was like, "This is the dumbest thing I've ever heard." And then they were like, "We're flying you to San Francisco to do it and putting you up in a nice hotel." And I was like, "I'm there." And I stayed with a friend of mine who was part of it. Is unfortunately no longer with us. Um, and we had just a great time. And part of that was like, okay, I got to set up my computer to live stream. Just I need to have done this once before I sit in front of this party full of people, and all these people have paid for me to So I started live streaming some development, and I was like, holy shit, this is it. Because the moment you press that broadcast button, you're on. You can't check your email, or you can't, goof around. You're on, right? So the amazing thing is, like, I'd say that in a 4-hour stream today, I do more work than I used to do when I used to work like 12 hours a day. So, so nowadays I try to do one stream every day. On a couple of days a week, I do two. I spend time, with a team. Usually I have to pick up my son around 4, and then I'm with him most of the day. And then when he goes to bed, then I do other things, and I do a little bit of writing. I try to keep up with all the C standard stuff, and I do all the, you know, hardware stuff and all that stuff. So
Wow.
yeah,
Wow. Okay. Nice.
I keep pretty busy. Let's just say that.
It seems so,
So
yeah.
yeah.
Uh, how do we get from there to Ministry of Flat? The UV unwrapper of
Okay.
you.
So this was kind of in the middle of all this. In the middle of all this, like, there was a lot of between I started making all the pretty graphic stuff. The graphics for the LED stuff, and then when that company went down, I gave all the stuff, and then I didn't have anything to do, and I was a little bit burnt out, and I was like, I don't want to start a new project. I want to clean up some old stuff, and I had this UVM wrapper that I'd written many years ago. That was kind of a goof. It was like I wanted to make a UV editor to begin with because I had, lots of tools and I didn't have a UV editor. And I made this little tool in it, which is if you clicked on a polygon that was UV unwrapped and then you dragged over the edge of that polygon, it would automatically unfold the next polygon, right? So it was just like fold out. So you could just like drag and fall, and it was really fun. It was like so cool. Like it was like, oh, I can unfold a little box, and it's like I wanted to go this way, and it was like, and it was one of those like sometimes you make a feature and you're like, this is the application, like and then I was like, well, if I do that, I could just like automate which edge it goes over, and then you don't have to do anything, right? So I wrote a little tool that did that. This was like many years ago, and I did it during Love's development, but Love didn't have texture mapping because so just to go back to Love for a second, one of the critical things about Love, and I think critical about like what I learned around that era, is that um, you got to be really, really smart about how you spend your time, and um, like you got to find what's your critical like advantage, right? And when I started making Love, there we go. Um, the thing that was cool back then in graphics was like Gears of War. It was like 360 times, right? So everything was kind of very plasticky because everything had bump mapping, right? And everything was like gritty, but everything had like sharp edges because you didn't have that many polygons. So I was like, okay, my game is going to be all flat surfaces, no bump mapping, but there's not going to be a sharp edge anywhere. Everything's going to be soft and curvy, and I'm just going to do the opposite of what everybody else does. And therefore it's like, let's not do texture mapping. I mean, I used a lot of textures and shaders, but like, let's not use texture mapping because I'm one person. If I have to texture paint everything, game over. It's never going to be done, right? So you got to be really smart about where you put your time, and I learned a lot about that. I mean, I think I knew a lot of that before I started Love, and the fact that it was released and was out and was a long list of smart decisions like that. So I didn't really have use for this tool, but anyhow, I back to closer to now. Um, so I was like, oh, I'll clean up the code for that because it was using like old libraries. And I was like, oh, I rebuilt all my libraries. Let's update everything. So I did that, and then I was like, oh, I can add this feature, and I can add that feature, and then I added a bunch of features, and then eventually somebody from Intel was like, you should show this at SIGGRAPH. We're going to get you a room to show this because this is cool, and you know, I had a bunch of friends at Intel, and Intel's been very nice to me over the years. And they were like, well, Intel, they want to show cool stuff they want to show their CPUs, but you can't show a CPU. You want to show something running on it. So they're like, okay, we have a booth full of stations. We need to put cool stuff in there. So I did this UVM wrapper, and they were like, oh, we'll give you a sponsored talk where you can talk about it. And I did that, and a whole bunch of people from the industry showed up. Lots of people were interested. And all of a sudden, people started coming out of the woodwork about licensing the technology. And eventually, I licensed it to Maxon. So it was a non-exclusive license, but so yeah, if anybody wants a license, it's still out there. Um, and so it's now actually in Cinema 4D. So everybody go buy Cinema 4D because they have the best UV wrapper in the world. And I spent, that was like a complete lucky break for me. And I finally made some money in my life. I was finally not poor. Um, and yeah, and that was a big, big thing for me, being able to do that. And so yeah, you can go to ministroflat if you want to .com, and you can download it and use it for free, even for commercial use. So for if you're an artist or know artists and they hate UV unwrapping, just download it and have at it. The only thing that is as long as you don't redistribute it or set up a service doing UV unwrapping, you're fine. And if you want to integrate it, then you license. So yeah, that's kind of it. Um,
It says that it picks one of the 14 algorithms for the UV unwrapping that best suits the situation. And I wondered what is the best suits part? Like, how does it pick one?
so essentially, I mean, this goes back to PlayStation 1.
Okay.
So when you're working on a PlayStation 1, you have textures that are like, let me remember correctly, I think there's 64 by 64 pixels, and you really, really care about your UV wrapping. You really care. And back then, most applications didn't have UV editors. So the thing we did was actually you model a whole model, you make a copy of the model, and then you move all the vertices in your model so that they become flat, and then you project on your texture on that, and then you move all the vertices back to where they were and look at the copy you made to make sure they end up where they were supposed to be in the beginning. So it was a terrible workflow, essentially. So I learned like all the rules of what's good UV unwrapping. And there's a whole bunch of papers about how to do UV unwrapping. And they all sort of use various heuristics for what's good UV unwrapping. And if you're an artist, you know that that's not really how UV unwrapping works. Like how you do UV unwrapping depends a lot on what kind of model you are and what approach you do. And, there's a lot of sort of tricks. And so what I did was I I wrote an algorithm that did all of those tricks. So you take a model and you unwrap it and you look at the results and you say, yeah, that's good, but I wouldn't have done that. Okay, write a thing to detect that thing and then write a special
Oh,
algorithm to fix that thing. And then you do that many, many, many times and just like push new models and just like, oh, now it regressed on this thing. Oh, okay, well, it felt this was like that. It's not. This is not actually this case. It's another case. Okay, we got a new detector here that can tell the difference between this and this. And you just like, you do that for 2-3 years, and you're really good at it. And then you get a really good UV unwrapper. So
human reinforcement learning. This is
yeah, kind of. Yeah.
awesome.
So
Okay. MinistryofFlat.com. And it's available for free. Like,
yeah,
okay.
I mean, if you're an artist, you can use it for free. But if you want to put it like automate your application by putting, there's a C library you can license and you can integrate into your thing, and it does everything for you. So yeah.
Okay. Now, you had an idea of re-engineering the internet, which is pretty
Yes.
cool. You
Yes.
must say it's pretty cool to have the idea to like reinvent the
I think a
internet.
lot of people have had that idea lately. The question is about like how.
Yeah.
So you're talking about Unravel. So
Yes.
Unravel is a long, long, long project that I'm not sure will ever be done. So it's sort of a research-ish project. I'm actually working on it quite a lot right now. I'm working on a library called Marshall, which is going to be pretty core to that. But the idea is sort of this, that right now on the internet, there's all this information and it's being stored on a bunch of servers, right? And I'm sort of questioning, why don't you store all that stuff yourself, right? It's like, why don't you have your photos yourself, right? And instead of you going to Facebook and asking them like, hey, give me a feed of all the stuff that you think that I'm interested in. Wouldn't it be better if you got all the information you were interested from the internet, or your computer got it from you, or, and then you had your own local database, and then you could have your own algorithm or way of viewing that information, right? And there's no ads, there's no, you control it because it's your machine, right? You can write your own algorithm for doing whatever you want. Like, do you want to see everything chronological? Do you want to see everything, like, however you want to do it? So to do this, you need a couple of things. First, you need a database and a data format that is really powerful, and that's what Marshall is. You need a storage thing, which is something else that I worked on called Keep, and then you need a network protocol where you can share this stuff, because what you want to be able to do is publish things on this network, but you can also just take things off of existing internet. So instead of you going to like 5 different websites to read your news, why can't your computer go to those websites and put that data in your um, database on your machine, and now you control it and you can view it however you want, and because you just want the information, right? And I want to put like the user in control. That's kind of the idea. So it solves a whole bunch of problems, right? It solves social media. It solves a lot of engineering problems of sharing. Like, sharing a file is still hard for some reason. And the whole internet is built on a monetization model that is just kind of broken, for several reasons. I mean, it's annoying with ads, and we can, but that's actually not the main problem. The main problem is that everybody tries to feed you like easily digestible crap information, because that's what keeps you glued to the screen, right? So they're trying to wrestle control over what we watch, and I think we should take the control back. So that's kind of the overarching goal. Then I'm also like wanna like ridiculously over engineer this thing, which is why it takes forever, because I want it to be awesome. So yeah, that's kind of the idea behind Unravel.
You mentioned a library called Marshall for
Yeah.
efficiently storing this, so compressing the
Yes.
information and store it.
It's not compressing. It's um, I'm very excited about it, but it's kind of boring in certain ways. It's think of it as a key value store, or a thing that can store data on disk. So a serializer, if you will, right? Think of it as like, oh, JSON is a file, and you load it, and then you have a bunch of data, and then you can save it, and you can load, a JSON file. You don't know what is in it, and like query it or build a UI for it. Except JSON sucks. And this is a binary format that um, has some really good properties. Like, one of the important things that it does is that has a it has a separate description of what's in the file from the actual files. So it mimics a computer very much, sort of C-like, where you have, a bunch of structs and other type defs. And then after that, you have allocations that are like chunks of memory. And one of the really cool things about this is that all the accessing of this data happens without unpacking it. So if you want to load a JSON file, what's going to happen in your computer is you're going to read a file, you're going to get a bunch of text, and you have to have a parser that parses that and makes a load of allocations and puts that in a tree structure, and then you can traverse that tree structure to find a thing. With my system, you take the binary blob, and you put that in RAM, or maybe you have a memory mapped file, and then you just say, I want this information, and it will just go into that and read it where it is. It won't have to take it out. It won't have to allocate anything. It'll be super fast. It's like finding, over here is the byte you want. Here's the data. So if you want to read and write something from a data structure, you can do that extremely quickly. It's very, very efficient. And then you can also use that, you can use the information, um, since you have a description that is separate, you can use that as a query. So essentially, I can send to you data, and I can say, here's my data structure, here's how I structure it, here's all the data. Good, right? And if I did that with JSON, every time I have, an entry called name, it would have to say names. I send that string name 1,000 times if I send 1,000 names, right? Here I would send that once, and then the data structure, and you can quickly find 1,000 names. So it's more efficient that way. But what I can also do is say, hey, I'm going to send this structure without any data because this is the information I want from you, right? And then you can build a UI from that struct. And if it's like, if it has a name and it has, your age and a bunch of things, you can fill that out and you can send back the data chunk to me, right? And now you can build remote control systems and things like that, where computers can talk to each other, because it's a way of not just sending data, but requesting data and saying, this is, you can be a washing machine and say, this is the information that I need to operate. Like, this is the information about what I'm doing, and this is the information you can send to me so that I can wash clothes, right? And um, that turns out to be something that's very useful for lots of things. That kind of, you know, you can build like an app that talks to a system like this, and it can do anything, right? Because on the other end of this, it could be anything. So it's kind of powerful. Um, and then I'm truly, truly, truly going overboard with how complex the system is and all the fancy tools I'm building for it. So yeah, um,
For everybody
I'm
who
gonna give
is,
a good talk about it at some point.
oh, nice. For everybody who is interested, you also keep a blog, like a diary
Yes,
of what is
yes.
happening in the project. So you can go there and check out the latest diary, at least, to see what's
Yeah,
happened.
unravel.org. So
And how does this interact with the existing internet? What's the idea here? Because if, for example, if you want news, you need like API, it can or cannot be there somewhere out there. So,
So, first of all, I mean, it runs on IP, right? That's the first
mhm.
thing. So the infrastructure would be the same. And it's a database. You can take your data and put it in that database. And if that data comes from, you know, your photo library or your notes or your whatever, it doesn't matter, right? It's just like you can take them down from the internet. If that's like the old internet, you can scrape the internet, or you can have API access, or wherever you get your data, that's up to you, right? Um, but the idea is, I think, if like we need a way to store things, right? And if you think about computers, um, we have files, but they don't actually describe what they do, right? They may be called .jpeg, and then you know how to parse it, but if it's .bin, God knows what's in there, right? And and this is kind of the problem, is that like we have a file system on our computers that is kind of primitive, that hasn't really changed in, you know 50 years, honestly. Like, and there's so much more we're trying to do, and like on modern system, which means like mobiles, they try to hide the fact that there even is a file system, right? Because it's like, that's scary. Um, and therefore, we need something better, right? And I think the closest somebody's ever gotten to building what I'm thinking is actually Microsoft, who built something called WinFS, which was part of Longhorn, which is the disaster project that, um, you know, basically they were trying to make a new operating system, and then they failed so miserably that they had to start over and redo everything, and that became Vista. So
Okay.
it's like if you think Vista was bad, it was like the thing that was worse than Vista, essentially. But part of that was something called WinFS, which was, I think very wrong in lots of how it was designed, but had the right idea that like information on your computer needs to be accessible by everybody, right? If you have a calendar app on your application, like on your computer, it should just say like, give me the calendar. And calendar is just like a part of the computer, right? And the calendar application is just an interface to the, you know, and then if you want to use another calendar application, you just use that one and it uses the same data and the same, because it's on the same hard drive and it's not a problem, right? There needs to be a format like that so that people can build applications like that. And I think that's like a major sort of stepping stone to going forward in computing. So I think there's like a tremendous amount of like opportunities in that area. Um, so yeah,
Okay. At what stage the project is now?
I don't know. I've written like lots of pieces of it. Like I've written the local storage, and I'm now writing the actual storage system. And I've also written some of the networking, but not all of it. So it's probably going to take a long time. Right now, um, I'm just started a gaming studio, and I'm pretty busy with that. And the engine we're building, or I've built, is designed to be networked, but is not networked. And the goal is we're going to ship our first game, and then I'm going to make the networking code for it. And I think it's going to be built on top of Unravel. So we're actually going to use Unravel as sort of a, you know, our core technology, and use our engine as a test bed for tech. So so I'm hoping to spend more time on it next year. That's my hope, but I make no promises.
Okay,
So
it's perfect segue to Kel Solar, a new game development studio. Tell me more about it.
yeah. So so it sort of started a year ago, kind of precisely, with me building um, this engine, and I was like, I should make something with this." And there's a podcast called The Business of Video Games, with a guy called Shams, and I'd talked to him before, like just you know, and I knew I think he said on the podcast like, "I'm looking to start a studio." It's like, and I was like, I should talk to him because we're in the same city. Let's talk, because So I had breakfast with him, and he was like kind of excited, and it was like he was like very positive in many ways, but he was like, I can't commit to anything because I don't know. Let me like in a couple of weeks I'll know more. And I was like, okay. Um, and I was like, I'm worried about paying for people because I just like we burnt so much money on the LED stuff, and I was like, I want to hire a bunch of people. I want to be super lean. And he was like, well, there's a lot of education in Sweden, like for game development, and there's all these kids that come out and they're like they want jobs, and there's no jobs, and they just want to. They'll do anything. They'll work for any they'll work for nothing just to get a foot in the door. So it was like, and I was like, are they any good? And he was like, no, most of them are terrible. Like they
That's
don't know
awesome.
anything. But he says like pretty much in every class there's like one student who actually is like good. So if you can find that one student, like there are good people out there. You just have to look for them. So I was like, okay. And then he got back to me, like, or I don't know if I heard the news. I think he got back to me, and it was like he got the job as CEO of Arrowhead, the people behind Helldivers 2. So I was like, "Oh, okay, that's why he didn't wanna commit to anything." But I was like I kept that in my head and I was like, "Ah, maybe it's like," and I kinda did the math and I was like, "I can afford to hire 2 dirt cheap people for 2 years, and I can build a studio." And, um, I always wanted to start my own gaming studio, but it was like, I didn't want investors. I didn't wanna, this is, wasn't right. And then there was like another thing that happened, which is, so a little bit about my personal life. I'm single, and I've been single for a while. But a friend of mine, she was like, "I want to have a kid. Would you consider being the father?" Um, and I was like, first I wasn't sure, and then I was like, "Well, she's gonna have a kid, whether I'm part of this or not, and I think the kid should have a dad." Like, if the kid doesn't have a dad, that's like, so whatever even if I'm the worst dad ever and never hang out with this kid, at least he can find me when he's 15,
Oh,
or whatever. Like, so I think I was like, I'm doing, some kind of favor by just, so I was like, okay, let's do this. So we did like IVF together. Um, and after a lot of back and forth, oh, we got a son. And I was like, okay, I gotta help out. I was like, I need to, we got home from the hospital and I was like, I'm gonna stay with you for like the first, week or whatever, just so everything's in order and you know. And it's been 4 years now, and I have slept one night in my apartment since. So I pretty much live there now, and I'm very much a full-time dad. So I had this apartment where I come here every day to work. I have all my stuff here. And I was like, I'll just start a studio in my apartment." And I asked the co-op board of the building, is like, "Is that okay?" And they were like, "Oh yeah, no problem." So I was like, "Okay, I'm building a studio." And I figured out that if we can sell 15,000 games a year, then we're like pretty much break even. And that's not a crazy number. Like, that seems doable, at least. And I was like, if I lose all this money and we don't sell anything, I'm gonna have a lot of fun. So let's do this. And yeah, and I sort of, I got money. It's not, you get into the question, are you rich? And it's like hard. I'm very rich from my point of view. I'm very poor from rich people's point of view. Um, but I just realized it's like I don't want to buy Gucci bags for like I don't want to I don't drive. Like, why should I buy sports car? Like, I don't why. I like programming. Let's get a bunch of people programming. Like, so that's what I'm doing with my money. And I was like, let's do this, right? So then I just went out on Twitter and say, "Hey, I'm looking for junior game developers who want to program C and want to be mentored and get a really, 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 really terrible paycheck." And a bunch of people thought that was great, apparently. And I found 2 great people that I love working with. We're having so much fun. And yeah, I'm really excited about it. So
The really, really terrible paycheck was probably very difficult to say no to. And this is why they wanted to join. Did you seriously advertise this in such a way? Like, this would be.
yeah, I mean, I don't want to like I don't want to pay anybody badly. It's
Yeah,
just like I can pay you better, but then we have less time, so then you're very likely to be laid off soon,
yeah.
right? And the way I look at, like, I'm a huge student of like studios that are successful. Like, I visited Blizzard, I visited Lucasfilm, I visited, Sony ImageWorks, like a lot. I have friends at Pixar and, all these various places, and I'm always interested in like why do some studios make it work, and I read a lot about that. So I have a lot of theories on how to run things, and I really wanted to put it to the test. And I wanted to not have investors, so and not have shareholders. Um, I don't want the people who work in the office to have shares, and preferably that would include me, because I want the people who work in the company to be in charge. And I don't want like, when I retire, I shouldn't be like the dude that takes all the money when I'm no longer doing anything. I want to create something, a studio that is like self-sufficient for the people who work there. And so I'm thinking about like if it works out, if we get some kind of stability, I want to create some kind of different company form um to make it perpetual and not make it like something we're going to sell to Microsoft or whatever, right?
Okay.
That's not what I want to do.
Okay.
So,
So you have now two employees in a company, self-funded. You have a game engine called Phobos, right?
yes.
The company is called Kel Solar.
Yes. It's the same company that I've been using for 15 years. So,
Okay.
more 20 I've used that name.
And now we kind of, again, a very naturally transition into the general software side of things because you have a unique way of writing software and also interacting with software, and you apply these principles in your own company, in game engine and the games that use this game engine. So maybe we can talk a little bit about that, how your game engine looks like from the outside and how people interact with it to make games.
So, so we're talking specifically about the game engine. The game engine is really a manifestation of like the kind of game studio I want to make. So I believe very strongly that like whatever tools you use will inform how you do things, right? It's like it's the old adage of like if you're a hammer, everything is a nail, and it's kind of where we are right now. For instance, in the gaming industry, is there's a lot of games with a lot of pretty graphics and no gameplay. Because when you sit down in front of Unreal or Unity, you basically have here is your world that you build assets for. And that's what you do, right? There are game studios now that like don't have programmers. They're just a bunch of artists and they make pretty things and put them in the game. And and then you get games that are like that, and those games can be good, but that's not the kind of game I want to make. I want to make games about gameplay. I want to make, you know, games that are about interaction. So what I decided to do is I want to build an engine where it's as quick as possible to prototype and build gameplay as quick, as humanly possible. You should be able to try anything. And once you've made a prototype, the distance between prototype and final release should be as short as possible. So you shouldn't have to make a bunch of art and, it should be very, very quickly. And an example I take is like, let's say you want to do the shield mechanic from Halo. You get hurt and the shield goes down, you wait a little bit and then whoop, goes up again, right? You can implement the gameplay of that in like 20 minutes, right? It's just a little timer and it's like super simple. Um, but if you're in a real game studio, that is like months of work because you got to have a producer and you got to have like graphics design and concept art, and then you're going to have audio team and you're going to have like all of that stuff, right? And it's like, what if we could make something so that if you want to just try out that mechanic, you can get it on screen and get it playable in like maybe not 20 minutes, but in half an hour? That would be super powerful because then you can try all these things out and you can make cool stuff. So This engine is made for almost exclusively top-down games. That's what we're gonna make. Top-down 2D-ish games, but with some caveats. So some things are incredibly powerful. So for instance, you have a full geometry engine. You can do Boolean operations with anything. So that means building a game where you can destroy things or where you can, cut things or build things is like trivial. You don't have to build things out of blocks or anything like that. You can make any shape you want and fit it with any shape. As a proper physics engine where you can do physics on all this with destruction, you can destroy anything. You can split an object in half if you want. You have really, really powerful pathfinding. And pathfinding, that is where the nav mesh, the navigation mesh, is regenerated every frame. And that means you can do navigation in a asteroid field where everything you're navigating around is constantly moving, right? And that makes it super easy to do things like moving platforms, because not only is it built in that if you're standing on a moving platform, you will move with it, you can pathfind from that to anywhere and it just works. Also like super, super fast ray casting. So you can throw out 1,000 rays to see what interacts with what. There is a built-in query language where you can, like, if you're an entity and want to find another entity, there's actually a query language for that. So you can say, I want all entities of this type that has more than 0 in health and have this flag and is on the, is an enemy to me. Like, give me all those units, and you get those units, right? So there's a lot of things like that that are incredibly powerful. It also has a concurrency model, which is pretty cool. So all the game is designed. The engine is actually 2 engines. So there's going to be 2 implementations of the engine. One is the debug implementation, which is the one we're using right now, but it's designed so that there can be a high performance version that will be extremely multi-threaded. And all the threading is hidden from the user. So you can write whatever code and every entity in the world can run on a separate thread. And as a programmer, you don't have to care. It just works. So that means you can do like really, really heavy gameplay, like have lots of units, and that's not to say that that's what we're going to do, but that's kind of the freedom I want. I want, if you're designing something and it's like, what if there's 100 guards? You don't want to be like, oh, we have to re-implement everything because it's all like the engine can do 5. Like, no, it's like throw 100 in there. It's fine. Um, I also have this thing that I want to do, which is like a really cool anti-cheat system that
Oh,
I'm excited to try once we get to networking. Yeah, so everything is also deterministic. So the whole physics engine is all integer math. There's not floating point anywhere in the physics engine. So that's an extra challenge. And the whole geometry engine is integer only. So that's pretty powerful too.
okay. Okay. You mentioned something that like every entity can be on a separate thread. What happens if they interact with each other?
So it's actually modeled after an idea that John Carmack floated on Twitter a couple of years ago, where eventually you have 2 buffers, one which is the current state of everything in the world, and then you're building another buffer, which is the next state. And each object in the world can um, read from the entire current state, but only write to its own state, right? So you basically look at the world and interact. And then on top of that, there's a messaging system. So if you want to change another object, you can send a message to it, and then you can change whatever you want in that object. And that's kind of it. And that's enforced by all the APIs. So you can't really do it wrong. You can't accidentally write to something you're not supposed to. And then, each frame you flip those 2 buffers over. And that means all entities in the world can operate simultaneously. And that means that a lot of things get simpler because you can just do pathfinding in one go, right? Or things like that. pathfinding is actually so cheap that a lot of times, like in our current game that we're working on, most units do multiple path finds every frame because they're like, I wonder if can I walk over here? Let's do a full path find and find out how long it would be, and what materials we would pass, and it does all this stuff, and it's like it's so cheap you can, you know, I think I did a test where I had like 10,000 objects that were pathfinding per frame, and it works. So yeah, pathfinding's very fast.
Nice. I talked to Anton Mikhailov, who worked on Dreams at Media
Yeah.
Molecule, and he mentioned that Dreams had this idea of double buffering the game state. So they
Yeah,
had
there's a couple of games I think that does this, so it's not entirely novel, I would say. I think, yeah, I don't think that's super novel, but it's pretty clean the way we made it. Um, I've also sort of designed it to encourage people to be more careless in certain ways, and be more experimental. And that's kind of what I wanted the engine to be. I want it to be like this goodie bag of like gameplay stuff. And it's like there's all these things you can play with. And if you want like a new thing, it's like, oh, I need physics. Oh, there's physics here. Oh, I need destruction. Oh, there's destruction here. It's like just like use whatever you need and you can build anything. So and you can like there's an editor for like building a head-up display. So you can like just in your code say, I want this in my head-up display. And then it shows up in the head-up display and you can just like put it wherever you want, move it around interactively. So it's supposed to be very quick and easy to sort of try things. That's a big goal of the system.
nice. Nice. This sounds super exciting. Like this kind of framework to work within when you can try lots of stuff and you know that it was designed to handle large quantities, it's not like you're not afraid to break stuff when you're trying things out.
Yeah. And I think, I after I actually started company, I sort of came to the conclusion of what our goal is, or our goal right now. And our goal is to make demakes of our future AAA blockbusters.
Okay.
So let me break that down. So I was like, wouldn't it be awesome to be like Nintendo in the 80s and you could make like Zelda and Mario and Metroid 8-bit that was like cheap and fast? And instead of having to make like AAA, it was like, wouldn't it be awesome, right? And they realized it's like they built all those games and then they, were able to make the 16-bit versions of those. And then, you know, basically if you go to Breath of the Wild and you play Legend of Zelda on NES, it's like, oh yeah, I can totally see these are the same games. It's like as if somebody played Breath of the Wild and was like, no, you can only program on this thing. Make it work on this 8-bit computer. It's like, okay, I guess I'll do it this way, right? So I was like, why don't we do that? Like, let's think of all the AAA games we would want to make and let's build a franchise that is like this would be a blockbuster. But then instead of implementing as like this huge thing with 3D graphics, and it's like, okay, how do we deconstruct that and have all the gameplay and all the ideas and all of the, if you play like 8-bit Metal Gear Solid, you totally like, oh yeah, this is Metal Gear. Like it's 8-bit, but it's like it's Metal Gear. There's no question about it, right? So like, let's do that. Let's build let's ignore the fact that it's like 2025 and just like pretend that it's not and just like make small gains, but with an eye towards, if one of these are successful, maybe we get to do the 16-bit version of it. And if that's successful, maybe we get to do the AAA version of it. Um, and that's kind of how I want to build a business. I think what we will probably do, like if anything is wildly successful, my goal is probably to spin that off into a separate studio.
What?
Because basically success is a very dangerous thing.
You would spin off the success so that the original.
Yeah.
Okay.
Yeah. So like like the worst thing that happened to Blizzard was World of Warcraft. Because World of Warcraft made like 100x money of everything else, right? So it's like, who cares about anything else, right?
Yes.
It's, I
Yeah.
think
Yeah.
it was like, I think it was Francis Ford Coppola that said that like Star Wars was the worst thing that happened to film because it robbed the world of George Lucas. Because now he can't do anything else. It's like it's Star Wars. Of course he's going to do Star Wars, right? It's like all the other ideas are now, nope, it's all Star Wars, right? And actually, um, before they got bought, I actually got to visit ILM, Industrial Light Magic, and we were having lunch in their lovely cafeteria. And he said that like one of the guys I met there was like, we are 500 of the greatest visual effects artists in the world in this building, and every year we make a profit of $1 million. And over in the offices over there, there's 10 people working at Lucas Licensing, and they bring in $500 million a year. And it's like, when we argue over who gets the office space, guess who wins?
Yeah, yeah,
you
yeah,
know,
yeah, 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 yeah.
it's just like, it doesn't work, right? It's like, and that's kind of the problem, right? It's like Pixar should not make any movies outside of Cars and Toy Story, right? And they know that. That's why they're making other movies, because they know that if that's all they make, it doesn't work, right? They need, but you can just imagine how hard it is for them to go to Disney and be like, oh, we're gonna delay the new Cars movie because we want to make this artsy film about a little kid who, like, stop there. Like, so it's incredibly difficult. And that's why I think it's like, if you have a really successful thing, you should put those people, like, some people are going to want to ride that and do that. But if you have people who want to do, like, be creative and do new things, you got to let them do that. And having those two things in the same building is really, really hard. Like, there's a reason Valve hasn't made any games in forever. Because it's like, why bother? We have Steam, right? It's like Steam eats up everything, right? It's like, why would we make 100% of a game we make when we can make 30% of every other game that everybody else makes? Like, why bother, right? So it's like, it's really, really bad to have that imbalance. And that's why I think it's like, if we ever have a big success, we will start a company around that success, and then our studio will remain, a creative studio, and hopefully we'll make more successes, and that'll be great. But yeah,
I don't think I need to ask on which company you would stay, whether you would stay in the original creative one or would move to the success one.
I think it'd be a lot of fun to move to the successful for a bit.
And come
Right?
back.
It's fun to do the journey of like, wow, this is blowing up. But I think, yeah, that's probably not where I'm gonna stay. You're right. Yeah.
Okay. You have done the talk recently about how you write software and how you think about organizing large software projects. I don't think it makes sense to sort of repeat that, but if you were to extract some of the key ideas from it and summarize it quickly, what would be your suggestion?
So I think this comes from a background of developing software myself, alone. But what my way of working, and I've done this, when I was a CTO of, I guess I still am in a CTO, but when I had a team as a CTO of Shimmer, um, the idea was basically, let's not have everybody work on the same code base. Let everybody have their own code base, and then let's communicate over protocols and APIs. So if you're making something, make an API that does that, and then you're owner of that API, and you have to maintain that API. And you know, it's funny to me that, like, people use APIs like POSIX or Win32, or, you know, whatever platform they're on every day, and they don't have a problem doing it. But then they're trying to collaborate with the dude sitting next to them, and then it's like, this is a clusterfuck, right? It's like you can't get 100 people in the same building to work, but everybody can collaborate with, Brian Kernighan, all the old guys. Like everybody can collaborate with Unix, but nobody can collaborate with. So it's like, I think we already have a model for how to work together. It's like you make an API, you make it clear how it works, you make it stable so that people can depend on it, you publish how it works, and then they use it and you move on and you build something else. And that's really how I work. I build components and things, and I build applications that are built out of components. And like, that's why I'm a killer programmer. I can build things that most people can't build because I have everything, right? And I know how it works, and I have everything, right? And nothing shifts under my feet. Like, it's not like I'm not depending on Apple, who like every summer they're like, oh, we're deprecating all this stuff because now you should all use a new language. You should all write everything in Swift and forget about all the code you wrote because this is the cool thing. And then every year they're like, oh, we made some changes in Swift. So, all that code we asked you to write last year, that wasn't really a good idea. You should write this code instead. Like, that's crazy to me, right? That's like how anybody can build their business on that. That's insane, right? So to me, it's like you build really stable parts that you can trust. And, there are trustworthy parts out there that you can use. I prefer to write my own. But you build on top of that, right? And you get away from the whole thing of like, what's the least amount of effort I can do? Oh, somebody's done that. I found something on the internet. Let's just use that and hope it doesn't break, and let's, whatever. And you have this massive stack of like random crap. You have no idea how it works, and something changes every week. So everything breaks every week. And it's like, that is completely not viable, in my opinion. That's, nobody should develop software like that. I'm amazed that people are even able to ship anything, honestly, that way.
That's why you have this way to compare software to bridges, right? Like, bridges are not expected to change over time. It should be done.
Yeah, I mean, I'm just like, it was just like a random observation that like most things we have in our world, people build them and then people use them. And that's kind of the thing. Like, once you build a car in a factory and then somebody buys it and it's no longer in the factory. Nobody's like, there's not a team of people constantly maintaining it. But for some reason, software, like, and a car is like out there in the wind and the snow, and there's dirt and there's like, friction, and like, there's like things are beating up on cars. Like, they're not, software is just like bits. It shouldn't change at all, right? It's just like, if it works once, it should work forever, right? But no, people like need to maintain software. And that's why we get sort of, the situation where people say, oh, I remember when I had an Amiga and I could do these things, but now I have a modern computer and I can't do those things. And that's, to me, is like insane. How's that progress, right? So I think this like forever maintenance thing is really, really bad, right? And it's like, especially it's like, yes, the world changes and things change, but it's like, you should always start out with the, how do we minimize that? Like, you got to look at the risk profile of what you're doing, right? When you build a bridge, you're sure as hell looking at all the risk profiles. Like, you're looking at like, what happens if a boat hits this bridge, right? And you think about that, right? Because it's like, you cannot have the bridge break, Whereas like in software, like, oh, there's a startup now that are using, they have a server up and you can query that for this information. Let's make our whole software depend on that server being there and query this information. If that server goes away, if they don't get their next funding round, our software is going to break. And it's like, that seems good enough. It's like, and then you have a team of like 10, 15 people all doing this every day. And then you're like, oh, why can't we ship new versions? Why is this feature taking so long? Well, we were, busy fixing all the things that broke this week. That's just like insane to me. And the fact that this is like a controversial or a weird opinion to me is like baffling. It's just like, how isn't everybody seeing that this is clearly not the way to do it, right? It's just very strange to me. So yeah.
Yeah, especially back in the day when you were doing game development, you were shipping the game on CD, like on a
Yeah, yeah,
functional disk. So there was no ability to patch this, to update this
yeah,
like afterwards, because like there's like here it is, and now it's gone, and now it's at your
yeah. And
customers.
it's also like just like the business model is crazy. Like look at Super Mario we just talked about. Like 8-bit Super Mario. Like Nintendo is making a crap ton of money of that game still, right? It took like less than a year to make in like 1985 or whenever, right? And it's like here they are, like 40 some years later, and they're like, yep, breaking it in. Are we patching it? Nope. It's just like we made it once, it works still, and we're still making money. How is that not the dream of everybody? Like how is everybody's like, no, we got to spin up a bunch of servers, and if we ever get below this KPI, we're doomed. And we have to shut everything down and tell our, you know, users they can never ever use the software anymore. How's that's very weird to me how we've gotten to that point.
But I feel like there's the argument of like being able to fix something on demand, like you have a server and you can deploy anytime you want, compared to like shipping something literally, is just
Yeah.
so convincing. It's like, yes, I can change whenever I want, I can deploy whenever I want. And
And of course that's great, but the negative of that is you don't have to do anything because I'll fix it later, right?
exactly,
It's like,
exactly.
there'll always be another patch, let's get this garbage out and go to lunch, and it's like, I think that's a very bad, this is a very bad thing, right? I think we need to ship things and we need to respect our users for using old versions. It's like, do you want to update? No, like, leave me alone. This one works. I don't want new crap. Like, just like this does the thing. My life, I don't care about your life. Like, I don't care about your new features because the software you deliver to me does exactly what I want. And I'm happy to move on with my life and think about other stuff. Like, you're not the center of my attention, right? It's like, can I just exist over here and you know, I think that's terrible about that we've gotten there with software. Um, and yeah, it harms everybody.
I like when you go to like App Store or Play Store and you look at like quite popular apps like Facebook or Instagram, and you see the release notes for each version. They pretty much stopped caring. They just say like copy paste the same one line, like, oh, security fixes, some updates, whatever. And it's like every
Yeah,
time
it's
it's like
just,
whatever.
I
Like
don't
I
know.
don't even I don't even
Yeah,
care.
I mean, the state of computing today is very, very sad. Because I mean, the crazy thing is we're all running around with like supercomputers in our pockets, and they are so incredibly nerfed by the people, controlling them, that it's just insane. And um, I don't know. I have a dream to build my own execution environment someday because, God damn it, we need it. And it's like, I don't know. It's a startup that I need to make someday, because there's like the potential is insanely large. And for some reason, people think that building like an operating system is a lot of work, and it's totally not. Like, it's like BOS was built by like 30 people. It's like you can build like from scratch an operating system in a reason, like in the amount, like, what was it, like there was a dog walking app that got like $600 million in investment. Like, how is nobody trying to make a new operating system Like that's I don't understand that, I'm not an investor. This is not investor advice. This is investor questions. Like to me, that's like, you know, yeah. Especially if you look at how terrible like iOS and Android is, it's like everybody really hates them. Like everybody who's a developer, just like this is hot garbage, and everybody knows it. It's not like a secret. So it's not like they're like, oh, it's this super shiny thing, and look how polished it is, and look how well documented it is, and everything works perfect. And it's like, ooh, we would never ever be able to make this because it's amazing. No, it's garbage, and everybody thinks so, which is, yeah, it's fascinating.
I have a couple of points on software, but they were all coming back from your 1 hour talk about how you write your software. So maybe I will just highly recommend this talk to everybody who is listening, and we can move on into a couple of other questions still regarding how you write software. First of all, you write software in so-called dependable C, C89. Can you talk a little bit about, first of all, what is dependable C? And then, like, that's a very old standard. So people would consider like a pain to work within this environment. A lot of people. So what do you say about, like, how do you view this?
Okay, so there's a lot of different ways to think about this, but essentially, I think that I have a very different view of languages than other people. So other people seems to think that the hardest thing about programming is typing. And therefore, the more you can reduce typing, the easier it gets. So every language is like, look how clever you can do this. If you press this and have a bracket, then that magically means something else. And this happens. You don't have to do this. And it's like, whatever. And it's like, the road to C++ is paved with useful. Like there's a lot of useful stuff. And I just think that's not the problem. Like to me, the biggest problem is not writing code. The biggest problem is debugging code, right? You wrote code, you think you know what it does, but it doesn't do that. You need to figure out, right? Your computer knows what your code do perfectly, but you don't. And that's kind of bridging that gap is the hard part, right? It's like, why doesn't it do what I want it to do, right? And therefore, it should all be about being as simple as possible to read and as explicit as possible. Every step, everything that happens should be right there on the page, and you should see what happens and be able to follow it. And therefore, I'm like very against macros or overloading of things or meta programming or anything like that. It's like what you see is what you get. That's what's important. And C is the language that sort of weirdly was at the right time where they hadn't invented enough stuff on top, right? And it just happened to be sort of a sweet spot, in my opinion, right? And then everybody was like, well, I wish it did this, I wish it did that. And, you get all these languages that have like features and, fix this, fix that. And it's like, it doesn't get better. It feels better, but it isn't better. Like it hasn't, and it's like a lot of these things fix really, really easy problems, but they create, they make the hard problems much harder, right? The hard problem is knowing what's going on. The hard problem is knowing what went wrong, right, in your code. That's the hard part, right? The hard part is not you know, when you get something really, really gnarly, right? That is like very specific and very strange and doesn't repeat. And it's like, that's when you really need to know what's going on, right? And, you know, I've had a lot of conversations lately about zero initialization, and that's I'm going to make a video about that. Because basically, people say, oh, if you just zero initialize everything, then if you forget initializing something, then it'll just, do the right thing. It'll be fine. And it's like, yes, that will fix all your simple problems. where you forget that. But wouldn't it be better if those things failed and you fixed them properly? Because if something is set to, you know, FE binary, you will see right away that, oh, this was an uninitialized value, right? And then you fix it, and then it's end, right? But then you have something where you set it to null and it works anyway. Only what if forget to initialize something and then you reuse it and now you have an old value that sits there, but the first time you use it, it was fine because it was null, but the second time it's not fine because now it's an old pointer, and that pointer still points to something, so you follow that pointer, and now you think you're having a right pointer, but you don't because that's an old pointer, and now you're following that, and you're like, my algorithm's broken because, like, why is it pointing to this thing, right? And now you're like, you spent the whole day and you're like, why is this strange, right? And it's like, yes, you didn't have to fix all of the simple bugs, but now you spent a whole day with the difficult one, right? All those bugs where read from a pointer that was FE, you would have fixed that immediately. It's abundantly clear what went wrong, right? And that's kind of how I think about it. I want it to be as small as possible, right? So that's one end of it. The other end of it is, think about code as what we produce, right? As programmer, that's our output, right? That's what we make. And it's kind of our currency, if you will, right? It's like it's the value we create. So what would you want that currency to be in, right? You would want it to be in gold or something like that. Something that's going to be like, if there's a nuclear war, people will still value this thing, right? It's like, you definitely want, like, Nigerian dollars are worse than US dollars, which are worse than gold, right? That's kind of how you can think about it, right? So when you write code in, like, oh, there's this hot new language that some dude on the internet has made and it's super cool and everybody's talking about it, it's like, yes, you're putting all your investments in this existing in 5 years, right? But if you write in C, you're like, 50, 100 years from now, this is going to work, right? We're never going to get rid of C, right? And if you look at the various versions of C, you're like, well, most implementations have a pretty good implementation of C99 today, but not all. And when you get to C99, there's a bunch of things like VLAs that are not implemented everywhere, or like have all these issues. And, if you go further in the language, it's like, if you're into C23, which was recently out, you basically have two implementations that are alpha, right? That's, and that means that most platforms, lots of platforms, old platforms aren't supported, and, you're stranded with that code. And then on top of that, like, if you're trying to hire people, most people have never seen C23 code. It's like they couldn't know what it does, right? And then you're like, oh, I want to run my code through, this um, text editor. Oh yeah, I can't do syntax highlighting with this feature. It doesn't know what the hell that is. And oh, this processing thing that checks for errors, it doesn't support this, it doesn't support that. And oh yeah, there's like, this compiler has a bug in this thing, or this, this platform, this works differently. And it's just like, okay, makes no sense. Like, why use that, right? And then on top of that, I mean, I'm part of the VG14, and I think no one should write code in C23. Like, I think it's just a bad idea, right? I think there's features in there that just makes it a worse language. There's some good stuff too. There's, there's a lot of really good people in the C standard. I'm, friends with a lot of them. I appreciate them. But I think they're language designers. They want to design language. That means adding more stuff. And I think that, the reason we use C is to use a small language, and they want to solve all the problems. And I'm like, no, I'll write code instead, right? It's like, I don't want to do that, right? So I say that I use C 89. And in reality, I realized that's not actually what I'm doing. first of all, I'm cheating a little bit because I'm using like C++ style comments, but that's fine because I can write a tool to remove those if I ever come to a compiler that doesn't support it. So it's kind of fine. But then there's other things, like there's a bunch of rules, especially in C99 and C11, about like memory model stuff. And those things are very unclear in C89. There's lots of things in C89 they didn't think of. And then they've sort of clarified afterwards what it actually means. And therefore, every compiler that implements C89 follows the C99 rules on the stuff that is not in the C89, because they're like, what are we going to do? Well, we don't know, but it says we should have done this, so let's do
Yeah.
that, right? So you can't just say like, oh, ignore everything after C89. It's like you actually have to think about things. And there are things like things that have been deprecated, and you should not use those things because, like, if you run in a certain compiler, that may not exist, right? If if people make a compiler today, they may not bother with stuff that is deprecated. So it's not as simple as saying, oh, C89 and ignore everything else. So I kind of call this subset um, dependable C. Like what is the subset of C you can depend on? If you really want your code to last forever, you want it to be simple, you want it to just work, right? And it's like when I came to the Maxon studio and I actually went there and handed over my source code, and I'd given them the API beforehand. They run on 3 different platforms with 4 different compilers. And my code was running on all platforms and all compilers the first day, right? And you can't do that with anything other than a subset of C, right? And that's kind of the thing about C that I recognized there, because it was funny because I was like, they're all C++, right? Maxon uses C++ like most people do. And I was like, yeah, I'm sorry, it's not C++, it's only C. And their reaction was like, oh, no, no, that's great, because it's like, C you can trust. Like, people come with C++ and God knows what they've done then, it's like, and that's kind of true. It's like a lot of people don't like writing in C because it's like, oh, I don't have all the niceties. But it's like, if you want to use somebody else's code, it's like, yeah, you give me C89, no frills, compiles everywhere, no bullshit, no, special magical tricksy stuff. No, no, no. Don't want that. Want dependable C, right? So that's kind of what, you don't want to write any C++, but you wish everything was written in well-written C. Like if every application on your computer was well-written C, oh my God, everything would be fast and good, right? And so I'm like, I think you should write the thing that other people want, right? That's kind of, so I had this, when I started in the C standard, I had this proposal for a feature called break break, which would allow you to put multiple break statements in a row and therefore break out of multiple um, loops, right? And I proposed it, and people were positive about it. People were like, I didn't propose like language for the spec. And usually you propose like a proposal. It's like here's what I would like to do, and then people say, we would be interested in putting this if you write the actual standard text and do all the work. So people sort of give you a hint of like, is this going to have a chance of succeeding? And it was pretty positive. People were like, yeah, this is um, and then I realized it's like, if we put this in the standard, I would never ever use it. Like, and how can I put something in a standard that I would refuse to use myself? And that sort of made me think like, why am I doing this? Like, I don't want to use this, new language. I just want something that's dependable. And that's sort of, and I also saw that, like, especially at the end of C23 and C2Y, which is the next version, like, people just wanted more stuff. And I could just see that this is going to be a language that I really, really don't like. And instead of being the guy who like argues against everything and everybody hates, let's just let these people build whatever language they want. And, I'll do my language already exists. I'm cool. And you can do what you can destroy this. And I mean, I think a lot of people are like that. Like lots of people have sort of embraced C99. C11 is very similar to C99, but has some fixes and has a proper memory model, but it gets very, very complicated. It has a concurrency model, and the model is pretty good, but the actual implementation doesn't work for a lot of complicated reasons. And therefore, I don't recommend using it. So yeah, what I kind of decided was that, like, since I'm interested in writing dependable C, I should start just documenting this stuff, because I hear about all these crazy issues people have on a mailing list and nobody else, if you're not on this mailing list, which is very obtruse, you're never going to learn this. This doesn't exist anywhere. Like, we had like, so let's put like, for my own, everything I learn I will put down on a website, and just like, I'm calling it dependable C, so that other people who can use it. And it's not a dialect, it's a subset, right? I'm not trying to make a new like, there's lots of people making like, here's C but with more features. I'm doing the opposite. This is like, you know and it's also, there's some things about the standard where there are things in the standard that are like, technically it's unclear if it's undefined behavior or like what you're allowed to do, but in reality they are completely dependable. And if you ever write a compiler, you should know about that, because if you don't, no code will actually compile in your compiler. So there's a little bit of like hidden knowledge there. And people hate on compilers for like, oh, you do crazy things with your code, like you optimize in crazy ways. There's so many ways that compilers can optimize according to the standard that they don't, just because they know that, like, we get so much hate mail if we did these
Yeah.
things that are completely legit, that it's like, we don't want to explain to people why they're writing broken code, because, so um, I think my view of compiler people have definitely changed. They're very, very responsible people. And yeah. So I think there's a lot of hidden information. Uh, we had a very, very weird conversation where somebody pointed out early on when I joined, it was around 2000, where somebody said that if you read memory from malloc that hasn't been initialized, on some platforms, if you read the same memory twice, you may get different values. And that blew people away. How is this possible? And it turns out that on some platforms, I think it was like some BSD or maybe Plan 9 or like that. What happens is, when you call malloc, you don't actually get memory. You get address space. And then when you start writing to that memory, then you actually get pages. But if you read from the memory, you don't have a page. So it will just give you a random page. So what can happen if you read memory, you can basically get a random page, but it's not assigned to your process. And then another application comes by and says, "Hey, I need some memory." And the OS, well, will take this page. He's not using it. And then you go like, "I want to read from this address again." And the OS goes like, take this page." And you get another page, and you get different memory, right? So this is a real thing. That's like, this is real. That this is not like, oh, it's UB, but this is real hardware in real deployment in the world. And everyone is like, "Oh, is this really legal? This sounds crazy." And one of the guys who'd been there forever, he was like, this came up after C99, and we had this huge discussion. And after the huge discussion, we all agreed that, like, no, it has to work this way. And then, like, after C11, everybody was somebody was like, did you know it can work like this? And everyone's like, that's not possible. And then they had a huge discussion again. And in the end, they all came to the conclusion, it has to be this way. And then when I arrived 10 years later, we had the same discussion again,
Yeah.
right? So every 10 years, somebody brings this up and everyone is like, that's crazy, right? So it's like, maybe somebody should write this stuff down. And maybe there should be a repository for these crazy things. And that's kind of what it is. And I'm incredibly busy, so I'm writing very, very, very slowly. But that's what dependablec.org is about. And if anybody finds weird behavior of C on weird platforms where like things don't work as you expect, like send them to me because I collect this stuff now. So yeah.
All right. I want to move to the section of your topics. You mentioned that you believe that engineering is massively underestimated.
Yeah.
How, in what way?
So okay, so I want to like, this is getting more philosophical, but imagine if I don't believe in climate change. Like I'm a dumb idiot who like refused to believe facts, right? And it's like, and you're like really mad at me for this, and you're like, I'm gonna change his mind, right? And it's like, imagine the amount of effort you have to put in to change my mind, right? And it's like, imagine what is the chance that you will succeed? What's the chance that I will go, oh no, you're right. I see the light now. Now you showed me the graph that changed my mind, right? It's like, what's the chance of that? It's pretty
Yeah.
low, right? So there's a lot of effort for a low chance of success, okay? And then you realize it's like, now you've done this, right? Like, what now, right? What, like, I believe in climate change. I'm not sure that I'm like saving the planet a huge amount compared to if I didn't, right? Maybe I, vote slightly differently. Maybe I, but it's not like, it's not a big deal, right? You're not saving the world by convincing me. It turns out that it's okay if I'm wrong, right? It's like there's gonna be a bunch of people who think the world is flat, and that's okay, honestly, right? They're not gonna change the world. Like if you're dumb enough to believe that the earth is flat, you're probably not gonna like invent the next thing or like be a power player in the world, right? It's like, it's sad. It would be great if you didn't believe that, but it's like, the world moves on is kind of right. And if you look at the world, the thing is that the people who impact the world are people who actually build things, who make things happen, right? And it's like, you know, for all his faults, and God knows there's many, like nobody believed that there was an electric car that could be made. You know, we spent decades making jokes about like, well, what are you gonna do when the cord runs out? Right? But one dude said, I'm gonna build an electric car company, right? And he built a little roadster, really expensive for rich people. And everybody say, well, yeah, sure, it's a car, but it's only a car for rich people. It doesn't even have a roof. It's bullshit. And then they made a real car, but expensive car. It was like, yeah, but nobody has afford that. Okay, it's a real car, but no. And then they made the next car, and everyone's like, holy crap, now we all have to make electric cars, right? And it's like, you don't actually have to convince anybody of electric cars. Like, he needed to convince 200 people to buy the first electric car, right? You don't need the world to believe in electric cars. You need to find a couple of hundred crazy people who have money, right? And that lets you go to the next step and do the next thing, right? And it's like, I think about that a lot. It's like the people who change the world are people who build things and make things. And you can hate on Mark Zuckerberg for many reasons, many legitimate reasons. And I'm one of those people who think that if you would rank all the people in the world from highest to lowest, you know, most suitable to run the social interactions of the world, he'd probably be in the bottom 10%. Like that's just my guesstimation, right? If you want a person who understands humans and, Mark Zuckerberg is not at the top of that list, right? So why does he get to run all this stuff? Well, because he built it, right? He sat down in his dorm and built the social network, right? And if we took all the energy that people have taken complaining about Mark Zuckerberg, we could have built anything. Like
Oh
there's no
yeah.
limit to what we could have built. Like we could have built bridges just out of the angry articles about how he's destroying the world. Like we could have, there's no end in how much people spend their energy protesting, and it's like, we'll build something instead, right? It's like, if you think there's a better way to build it, and God knows I do, like, build it. Don't complain about it. Because in a certain way, I think like Mark should get to keep his social network. It's the rest of us who are stupid enough to use his social network that needs to, if he wants to build a social network, go have at it. That's, I'm not stopping Mark. Go be Mark, that's okay. I can live with that. Like, I think, and there, I think a lot about that, I think about the power of that, right? And like one example is like people are mad about like plastic in the ocean, right? And that's a great thing to be upset about, right? It's a real problem, right? But how are we going to solve that? And if you think about it, it's like there's so many people out there that are like, I'm going to tell my neighbors to sort their garbage, right? And I'm going to be the annoying person that does that. And people will put a lot of effort into that. And it's like, that's not a bad thing to do. You're not an evil person. But is that going to save, you know, plastic in the ocean? Like, even if we, have a massive change in social behavior, you know, let's say only 10% of the plastic that ends up in the ocean ends up in the ocean. That's way more plastic in the ocean than is okay, right? It's like, that's not good enough, right? And if you think about it, it's like someday somebody's going to invent something like plastic that is safe to have food in, that you can put in water and that dissolves and becomes harmless. Somebody's going to invent that thing, and it's got to be really cheap to make. And there is probably, here's a rough guess, 50 people in the world working on that problem. And that means that if you decide, I'm going to do that, I'm going to be a chemist, I'm going to, read up on it, I'm going to try to understand this is what I'm going to do. You just like, you're 2% more chance that we'll solve this problem, right? You just like, that's a pretty big change, right? You know, and it turns out that these 50 people, they all talk. So you can
Yeah.
probably,
Yeah.
they go to some conference somewhere. I don't know which, but there's somewhere they're hanging out. There's a Discord for them. And if you just find that area and figure out, and you just like talk to Nestle about like, you make all this plastic wrap, what would make you change? And not talking about like, how do we convince you to change? Like, what would make you wanna? What's the requirements for this plastic? And then go build that, right? Maybe you can just solve a little corner of that problem, but you share with the other 50, and somebody's be like, I know how to solve the other part, and I know how to, that's how you're gonna change the world, right? That's how you're gonna change the world. And it's funny to me that it's like, we live in a world that is drastically different from 100 years ago, right? And if you look at how is it different, you would say the internet, you would say computers, you would say, phone in your pocket, film, TV, media, you know, everything that has changed. But then you ask people like, who are the significant people, the 100 years, and people start naming like politicians or people who had an opinion about something. And it's like, no, those people didn't do that. It's like, actually, it's like, I think about that a lot when we talk in the C standard. I'm thinking about like, we, I'm a very hard protector of the performance of C, right? And people come in and say, oh, if we make this change, C will be safer to use. And we will lose like 0.5% of performance, right? That's what people say. It's like, oh, that's negligible. And then I have to like raise my hand and be like, okay, that means every phone in the world, every data center computer now runs 0.5% more energy. That means that the world now needs, we now, our batteries on everything is going to run out 0.5% earlier, right? What's the accumulation of hours of battery time we're losing for, 8 billion people, right? What's the, let's say that Google and Amazon and um, Microsoft now have to build 0.5% more data centers in the world. Like, what's the cost of that? Like in terms of hardware, right? And you realize it's like insane, right? It's like, so I've fought very hard for various things not to change or for like optimizations to be allowed. And I don't want to say that I was the tipping point or I was the one who, made them see the light. There are lots of people. We're all talking together. There's lots of good points, but I'd like to say that, there's 30, 40 people of us. If we save 1% of all computing energy, like Greta Thunberg, go to hell. Like, we're way more efficient than you are, right? Like, I have nothing against her. She's great. I like her. But it's like, in terms of efficiency,
Oh
like
yeah.
who should be on the cover of Time magazine? Is it like it's a bunch of nerds like in a conference room that nobody cares about, right? But in reality, every you know, every environmental journalist should be outside waiting in anticipation of what we're going to come out and say, right? But that's not how the world works. Like, that's how the world actually works, but it's not how people think the world works. Like, people think it's like, oh, we're going to go to, you know, a conference and we're going to sign a decree and things are going to be solved. Like, no, people, they're actually, um, I mean, I think a lot about, like, do you know who Fritz Haber was?
Oh,
So Fritz Haber was a chemist who won the Nobel Peace Prize, and he did a lot of terrible things. He invented mustard gas, and he also invented a gas that was so dangerous that you had to, because it didn't have an odor, so they had to put like an odor in it because it was so deadly. And then the Nazis realized they could remove that and call it Cyclone B
oh yeah.
and use it in concentration camps. So yeah, so the guy's responsible for like 8 million deaths or like lots of people. Like his negative account is very, very big. And when he won the Nobel Prize, nobody would shake his hand, and his wife shot herself because, yeah. So, but the other thing he did was he invented the Haber-Bosch technique, which was essentially how to make fertilizer. And, if you go back and read history in
Oh
Europe,
yeah.
you know that, like, oh, every 30 years there was a famine and like 20% of the population died, and that doesn't happen anymore. Like, we just have like infinity food. And why do we have infinity food? Because fertilizers. He invented how to do that. And there's estimations that says that if he didn't do that, there would be 1 billion less people on this planet.
Oh yeah. Oh yeah.
And that just like, I just like that as a history of, like, I mean, it's both really hopeful and really dark, but it's just like if you make a list of people who have impact on the world, like, that guy should be ahead of Napoleon and, everybody. Like, who cares what the, kings were called? Like, that guy, it's like there's a billion with a B people alive today that wouldn't be alive, wouldn't exist if it wasn't for invention. And there's like millions of people that would have been alive if it didn't do all the bad things, right? So, not giving the guy a pass, but I think it's like really important to think about that, right? And that's like, we have this amazing ability to impact our world, and it's never been easier, frankly. You can make things like my dad, he would go to like he would have like have to wait for like 2 months to save up money to buy an electric drill when I was a kid, and he had a pretty good government job, And today I saw a electric drill on AliExpress for $2.50, right? And it's like, you can't complain about not having the tools, right? That's not okay. I'm sure it's a terrible drill, but if you just need to make a hole, like $2.50, right? And it's like, I grew up in a world where like I had to go to a community center to get a computer, right? And when I wanted to learn something, if I want to learn a programming language, I go to the library, and there's like, no, we don't have that book. But if you write it on this list, in 6 months, we're going to have a meeting about what books we're going to buy, and then maybe we'll buy that book, And today you go on YouTube, and it's like, what do you want to learn? Like all of MIT's, every class that MIT gives is there. It's like all the coursework, it's just there. Like imagine how impossible it would have been to get access to that information 20 years ago. Like the tiny percentage of people who could get a taste of that. Today, like if you're living in the slums of Mumbai and have a $50 phone, you can watch that. You can learn all of that, right? All of that is just like available, right? So there's like a tremendous amount of opportunity, and you don't have to do it like the startups do it. You don't have to go to Silicon Valley. You don't have to, code like the pros do, or do it like Google does. Like, forget about that. Just do it your way, right? It's like, and that's why I think it's like, people need to start looking up to engineers, and we need to, as engineers, we need to prove that to people, show that to people, and show young people, if you think the world is hopeless and that, you can't do anything, it's like, no, you're not looking. You're looking at social media about like how terrible the world is, but you're not seeing what can be done, and the changes you can make, and the impact you can have. And I think that's really, really important to communicate. And that's why I wanted to say that on this podcast, because I hope, people listen. I hope there's young people listening, or hell, I hope there's old people listening, because there's a lot of old people who think that like, oh, I'm 50 now, I don't have to do anything. I'm going to, write an emulator for the computer from the 70s instead of making something useful, So it's like, yeah. And I think that's a revelation that I've had in the last couple of years. I think I've always had it a little bit, but it's really, really crystallized, and it become very important to me, I'd say.
Awesome. Look, normally I would say it's a perfect place to end on this like high hope note, but I gotta tell you now 2 comments, okay? So I will just like...
Okay, go for it.
1 comment. First, this exactly happened to me like for this podcast. I wanted to see like this place where people would talk about like technical aspect, often about game development, and I couldn't find it. And for the longest time I was in this like nihilism kind of cynicism loop, and I was like, this is bad, this is worse, a job, oh my god, this code, this sucks, like, oh, why not? And at some point I was like, I will build something. And I built this, and I get so many friendly and happy and excited messages from people in comments and directly, the people that are crazy happy that this podcast exists, that they could listen to these conversations. Like, there's nothing like that. And I'm like, yeah, I know, but this is like, I was looking for this and I couldn't find it. This is why I started this, and this is super fun to get something and try something. and get better at it, but also like you can build stuff, and it's much better to be on the building side than on the cynical side and saying that everything sucks.
And it's also like there's a lot of things like I wish I knew this one as I was younger. It's like you have all these people who are amazing at stuff, like people who've been around forever, like whatever heroes you have, right? And they work in regular offices and have regular problems, right? And it's like, um, I was like, I implemented OpenEXR, which is image format for high dynamic range images. So I joined the working group for that um, there is the Academy of Software Foundation, which is part of the Academy of Motion Picture Arts. So the Academy Awards, those people. So they have a bunch of technical things, and there's like there's a software part, and they maintain a bunch of software. And one of those is OpenEXR. So I joined, these things, and all I wanted was like, can I get a specification? I would like to implement this, and eventually I got that. But one of the things is like, you end up in this Skype call with like 4 or 5 people, and there's like 3 of them have like Oscars for like visual effects, and one of them is from like ILM, and one of them is from Disney, and one of them is from Beta or whatever. Like there's these like people, and they're all like, yeah, somebody should clean up the documentation, or like should rebase this thing. And it's like, yeah, I'm busy. We're like, we have a show that is coming out, and yeah, and I'm like, man, if you're a student, just like do that grunt work, and all of a sudden like the top guys at these top places know who you are, and you're like, yeah, that guy's cool, he did that thing right now. And it's like, you don't have to invent anything, you don't have to it's just like do the boring stuff, right? It's like everybody has like code that should be cleaned up, or like updated documentation, like there's stuff like that. And I think it's like there's so many things like that, and I think this podcast is such a great example of that. It's like they're just like, I mean, I would love to have a podcast, but I don't have time to have a podcast like that. I want to, I want somebody else to invite me on their podcast. So I can't be, so having somebody who's just like, I'll do the podcasting. Great. All of a sudden everybody knows this guy. He does, the podcasting. Great. Everybody loves him. Right. And it's like, sometimes it's really, really easy to contribute, even when you don't know, even when you're not in the situation of like, oh, I'm going to build the next Facebook, or I'm going to, if you're the guy who wants to solve the plastic in the ocean and you don't know anything about plastics, go to the plastics people and you'll find out they have a stupid problem that you're like, yeah, anybody can do this. I'll do that. Okay, now all the plastic people like me. Now they will let me into their their plastic discussions, and I can listen in and try to look up all the words I don't understand so that I can eventually figure this thing out, right? It's like, it's a lot easier to do that than people think, right? And it's like, because the problem is there's not that many people who care about plastic. So there's not some heavyset guy who's like keeping all
Oh yeah.
the the plastic groupies out, all the plastic wannabes. Like there's no plastic wannabes. Everybody's welcome in the plastic gang. So it's like, and it's just like, all you have to do is just like figure out where they're hanging out, and go there and just make yourself like vaguely useful, and you're in, right? That's every field. Like I heard people complain like this is years ago that like emojis um didn't have like all the races,
Yeah.
they do now, but they
Yeah.
didn't have all the, and I remember looking up like the group that sets emojis, like the membership fee is, I think it was like $25 a year. And it's like, how about you don't argue on Twitter and just pay 25 bucks and write a paper and get it approved. And there you go. You've changed, like, you want your own emoji? That's what it costs to make your own emoji, right? It's like, it's not that hard, right? But people like being angry and being
Oh, yeah, yeah.
protesting and saying, these people, they don't understand. It's like, no, they're just busy with other
Yeah,
stuff,
yeah.
right? They just like they have a deadline this week. That's why this isn't happening. They're not against your idea. They're just like, you know, they have other things,
Yeah.
right? And that's kind of, I wish people knew that.
The
I wish I knew that when I was younger, at least.
the angry people and angry comments. This is the second comment I need to make about your speech in the last part. There's this video, the interview with Jonathan Blow. It has 3 hours on this podcast, and around 2 hours and 30 minutes, he mentions Elon Musk, and he says that
Okay.
he likes Elon Musk. If you look at the comments, there's like more than 300 comments. I think largely more than half comments is like, I love Jonathan Blow, I love game design ideas he has, but I really dislike his opinion about Elon Musk. And it's like this angry comments. And what I'm thinking when you're saying exactly at 2 hour 30-minute mark of this discussion, you mentioned one guy who made electrical cars possible. I'm thinking,
Oh God,
first
no.
of all, how ironic that you're talking about angry comments and people that are like throwing a lot of emotion and effort into commenting instead of building something. And I'm thinking, if we can get more comments that will ask you to do a love version 2 game instead of the angry comments because you mentioned Elon Musk, that's a win.
Yeah.
That's a win.
I think it's really important that we don't buy into the idea that everything has to be binary, right? It's like, I mean, let's leave Elon out of this, but let's talk. I mean, I just meant Haber Bosch,
Yeah.
like a guy who literally invented gas to kill people.
Yeah.
Like that, it wasn't like he invented a gas and then someone else. No, no, no. He ran a weapons lab, right? And it's like there we need to be able to talk about people as complex beings, right? That you know you can't deny that he, you know, fed a lot of people, and you can't deny that he killed a bunch of people. Both things can be true at the same time. And there's a lot of people on the internet who don't like that fact. They would like the world to be black and white, and it's not. And I think it's really, really important that I think the majority of the world understands that it's like that, and we should not cower to the people who thinks that, you know, that everything is simple, right? And therefore we should be allowed on a podcast to say that. And if people want to make it about Elon or whatever, okay, do that. But I actually have the power to ignore you then. Like that's not important. I mean, to me, Elon, I've met Elon. We actually made a light show for his birthday party
Okay.
while I was doing all the LED stuff. And it's like, I think he's a fascinating guy. Like he's, you know, I know some people who know him well or know him better. Like I briefly met him. Um, and from what I understand, he's pretty deep in a hole right now. And I think everybody can see that, or most people can see that. But it's also like it's really complex, I think. It's let me say this. Let me say this. And I've I've gotten to know a couple of billionaires in my life. And if you get to know billionaires, you realize that all the problems that we have, or most of the problems that we have, they don't have, right? And everybody focuses on that because it's kind of obvious, right? They don't have to worry about money. That's the first thing. They can go anywhere, they can buy anything. It's like, that's very obvious. But they also have some really big challenges that regular people don't have. Like what happens when you have people around you that arrange everything for you, and it's really, really easy to lose grip of reality, right? It's actually really, really hard. And it's like, I'm not going to name any name, but I know somebody who basically had the problem of like, essentially, like, he said in an offhand comment that is like, "Oh, that's a nice car." And then like that car showed up in his driveway and he was like, "Why is this car here?" And people were like, "Well, you said you liked it, so we bought it for you." And he was like, No," right? Because it's like people trying to be helpful. Like, because, last week you said, get more cornflakes. And now, you said get car. So we got car. Right. And it's like, that's insane. But it's like, it's easy to end up in that bubble. Right. And it's also like, it's somebody said, which it's like, I think about a lot, which is that once you become a celebrity, you stop aging. And what they meant by that is that the moment you're a celebrity, people stop telling you off, right? Pe- people don't people don't tell you to stop f***ing around, right? And that means that like when people tell you you've done wrong or that's when you mature, right? That's when you grow as a human. You don't grow when people tell you you're awesome. You grow when you're like somebody sits you down and is like, "Hey, you got to stop this thing," or like you got to treat that person better. You got to apologize, like. But when you're a celebrity, like there's always people who's on your side. No, they were wrong. You should be able to do this, right? And that means that it's like if you look at Michael Jackson, he got famous when he was 5 years old.
Yeah.
He was 5 years for the whole his life, right? Look at Beastie Boys. They got famous, when they were like 16. And look at an interview when they're two guys who are like in the 50s and they act like teenagers. They're completely like teenagers. And it's like it's uncanny, right? And it's like I've learned that it's like it's things like that are really, really complex. And it's really interesting. Like some people can just do it, right? We all know celebrities that are just fucking cool, right? I think Taylor Swift seems like completely super cool. I know somebody who's met her and hung out with her, and she seems to be just like handle it like a champ, right? And but it takes a lot from a human being to have everyone around you say you're awesome and say no, right? I need to get some people who dislike me and around me and criticize me and make me do better. Like that's a very unnatural thing to do, and very few people can do it. So the fact that very rich people get really weird is kind of it's sometimes it's a very natural response to being in a very unnatural state, right? And that doesn't, it doesn't excuse things, of course. It doesn't, but it's made me at least realize like the complexity of that, and yeah, it's definitely given me an appreciation of like imagine talking to anybody in the world and they want something from you, right? A
Oh
nice
yeah, yeah,
girl
yeah,
comes
yeah.
up to you and she's like, how do you know she's not just like she smiles, she's happens like, I've been to parties wherever like there's this group of girls who are like, let's stand as close as possible to the billionaire. Right? How do you have a real relationship in that kind of environment? That's like those are not problems that you and I have. And it's like yeah. So it's I kind of want to give people a break, even though I can, say that, oh, that thing that person did was terrible, and they shouldn't have done that. But I'm like, I don't live their life. I don't know everything. It's really easy to hate on them, but it's like, I don't know. So, and I think it's important we say that despite whatever, you know, I'm sure that they're going to call me an apologist of some kind, and that's okay. You know, but I think it's important that the people who that we stand our ground, the people who think that the world is more complex and more intricate than a YouTube comment thread, essentially.
I feel like the YouTube comment friend under this video will be the most philosophical and like seriously empathetic. Like after
I hope so too. And honestly, I mean, I've gotten my fair amount of comments on the internet, and I would say that like the vast majority of it is awesome, right? And I think there's a very simple superpower you can get yourself, and that's realizing that like freedom of speech does not mean you have to listen or care. You can allow people to say dumb things without you responding or caring. And um, if you can realize that and live by that, the internet can be pretty awesome, actually. But if you get stuck in having to argue with everybody, and then yeah, it's not the greatest.
all right. We covered a lot of ground today, Eskil. Thank you so much for joining me. And let's shout out where people can find you when you're streaming.
Okay, so I am on Twitch TV /Kel_Solar, so QUEL_SOLAAR. And if you write kelsolar.com, that's my website. And for our studio, we're hopefully going to launch a game at some point. So please buy that, because I'd like to keep doing this for a little bit longer. And then what else? Websites. I have too many domains, but also I'm on Twitter, Eskil Steenberg. I'm on Blue Sky. I have my own YouTube channel. What else? Yeah, dependablec.org. Yeah, unraveled.org. So,
ministryoflat.com. I will put all of that
oh yeah,
in description. So don't you worry.
yeah.
Okay. Thanks. Thanks a lot, Eskil. This was super cool.
Well, thank you so very much for having me, and thank you for doing this podcast, because I enjoy listening to it, and I'm very, very happy that you exist and get to share all the awesome people and their stories. So keep doing it.
Thank you.
Yeah, you're welcome.